Everyone. Welcome to Anote's AI Day Summit 2025. We're really glad that you can join and make our incredible event. The goal of this event is to help make AI more accessible. We hope to bridge the divide between the tremendous potential that AI has to offer and the everyday tasks that people care about. We have thousands of attendees streaming from all over the world, from New York to Colombia, all across Europe, and we have some amazing speakers. First up, we have Neonika.
Thank you, Nathan. Good morning, everyone. I'm absolutely thrilled to be here to discuss a topic that is shaping the next wave of AI, which is physical AI agents. But before we dive into the technical depth of it, I want to introduce myself. So I'm Nyanika. I'm an MBA candidate at Cornell right now, with strong focus on product management and technology. So previously, I was working as an AI ML software engineer at IBM, and I was building AI powered solutions in Industry 4.0 and Gen AI. And my work has spanned across computer vision, models for robotics to enterprise AI solutions. So today, we will decode physical AI agents, what they are, how they work, where they are being applied, and what the future holds for them. So AI is no longer just software, and it is increasingly becoming a more autonomous and capable of interacting with the real world in a meaningful way. By the end of the discussion, my goal is that you walk away with something of deeper understanding of physical AI agents, whether you are an AI researcher or engineer or a business leader. So let's get started. So what are physical AI agents? In essence, these are basically autonomous systems that integrate AI with physical embodiments, enabling them to perceive, reason, and act within the real world environment. For example, imagine a self driving car, a robotic surgeon, or an autonomous drone. These are all physical AI agents. They're not only analyzing the data in a real time, but also interacting with with their environment physically. So at their core, they work on three fundamental capabilities. One of them is perception, which is they need to see, hear, and sense the environment. Second is computation and decision making. So they must interpret the data that they are collecting from the environment and make real time decisions. And actuation, which is making the move to interact with them physically. So let's break down each of these different pillars of physical AI agents. So the first one is perception system, which is the eyes and the ears of AI. So a physical AI agent is only as smart as its perception system. Um, for example, an autonomous vehicle is speeding down a busy city street. We all know about Waymo. And it needs to distinguish between pedestrians, traffic signals, road signs, and sudden obstacles all in real time. And this is where advanced sensory systems come into play. For example, visual sensors like RGB, infrared, and depth cameras, which allow AI agents to see and identify objects with incredible precision. And there are also LIDAR and radar systems that help them to create a 3D spatial map, which can detect distances and velocity of surrounding objects. There are other sensors like inertial measurement units, which track an agent's orientation and movement, which are crucial for drones, humanoid robots, and self balancing systems. Other sensors like tactile sensors help them to sense touch, pressure, and temperature, which are like human like dexterity. And other than that, microphones and audio sensors are used for speech recognition and environmental sound analysis, making voice controlled assistants much smarter. Now, the real power lies in actual sensor fusion, where data from multiple sensors is combined to create a more robust and accurate interpretation of the surroundings. This is what makes AI agents create informed and real time decisions. The next foundation is the cognitive architecture, which is basically the brain of AI agents, where they process, interpret, and act on that data. Um, a physical AI agent's brain is designed around one knowledge representation as to how is the data being organized, and it has to be in a structured and a logical way. The second is the decision making algorithms. So these are deep learning algorithms like deep reinforcement that enable AI to optimize the actions based on the outcomes. So reinforcement learning, which is inspired by human learning, enables them to continuously improve the responses based on the previous errors. Um, think of like a robotic warehouse system that uses deep reinforcement learning to dynamically optimize its movements. It needs to reduce energy consumption, increase efficiency, and adapt to workflows changing in real time. And this is the ability to learn and improve over time is what sets AI agents apart from traditional programmed robots. The next foundation is the actuation system, which is the motor skills of AI. So once an AI has agent has processed the data and made a decision, it now needs to make physical action on that decision. And this is what brings us to the actuation system. So one of them is electric motors. So it needs to have robotic electric motors in robotic arms and even in self-driving vehicles. Um, there are also hydraulic and pneumatic actuators which are used in heavy duty industrial robots and exoskeletons. Um, Another one is soft actuators, which mimic biological muscles, allowing for natural movement and adaptability. So these are essential in humanoid, robot, and prosthetic AI agents. A great example of this is how Boston Dynamics Spot Robot uses real time control algorithms to perform highly dynamic movements, for example, like jumping, backflips, and even running. And the combination of all these three, perception, cognition, and actuation, is what makes AI agents truly autonomous. So, coming to the current real world applications of AI agents, um, one of them is, of course, healthcare. We have heard about AI powered surgical robots like Da Vinci, which are revolutionizing manually invasive procedures. Moreover, autonomous vehicles, we've all heard about Tesla and Waymo, which are leading the race in self driving technology. Other than that, they're also used in industrial automation to move towards Industry 4.0 from manual industrial settings. And it helps basically in robotic processes and helping with predictive maintenance as well. Moreover, it is also being used in smart agriculture, where the farming equipment is equipped with AI and it optimizes the irrigation and crop yields while also minimizing the use of water and pesticides. Some other examples like defense and security, how autonomous military drones and robotic surveillance systems are advancing national security, as well as space exploration. NASA is using their Perseverance rover, which is autonomously exploring Mars using AI. So the integration of AI with robotics is no longer futuristic. It is here now and evolving at an exponential pace. But of course, it has its own challenges. And one of the biggest challenge is safety and reliability. Can we really trust these AI agents in high risk environments? Um, let's say it's on the road and it's an autonomous driving car. We need to ensure that there is less than 1% error. Even if there is 1% error, it can lead to thousands of accidents per year. Moreover, we also need to address the ethical concerns. For example, How will these AI agent robots make ethical decisions when they are using so many sensors, that they are using microphones, they're using cameras, and these surveillance data needs to be handled very carefully. Of course, when these AI agents are being used in the real world, there is also the fear of job loss because manual processes are being replaced. For example, people working in manufacturing settings, they are being replaced by robots on the assembly line. So, moreover, autonomous weapons. How can we ensure that these weapons are used for national security and not for other things? And and hopefully they don't really act according to their own uh, will and power, right? The other thing is legal and regulations. So we know that governments all over the world are trying to create frameworks now that they realize the power of AI. But who is legally responsible when an autonomous AI agent makes a mistake? Is it the robot? Is it the person like operating, let's say, an autonomous vehicle, or is it the government, or is it the company? So these are all good questions we should ask while we are harvesting the power of AI. Having said that, this technology is currently being used by top companies all over the world. And some of the latest developments, which is shaping the future of physical AI, can be seen through the NVIDIA's Cosmos platform, which is a revolutionary toolkit for AI powered robotics. And recently, even the CEO of NVIDIA had talked about how he believes physical AI agents is the next big thing. And Cosmos basically is a powerful suite of tools that integrate the World Foundation models with advanced simulation capabilities, which allows researchers to build more intelligent, adaptable AI agents. Moreover, there are also like bio-inspired robotics, which is the merging of biology and AI, that is revolutionizing exoskeleton and soft robots. There are also other examples that are being used by Llama, which is the open LLM family, and also Salesforce, which is using the AI powered retail platform that is transforming the retail workforce management with AI augmented solutions. So I would want to talk about the emerging trends other than the human robot collaboration, and I believe that these AI powered physical systems will become as common as smartphones. I want to like really leave you with this thought that AI is not just about machines replacing human efforts, it is about amplifying the human potential. And as researchers, business leaders, and engineers, it is our responsibility to ensure that the AI serves humanity in the best possible way. So I think we need to continue pushing the boundaries, questioning the ethics, and shaping the AI revolution together. Thank you so much for your time, and I look forward to any questions.
Thanks so much, Yanika. This was like an amazing presentation. I personally learned a lot about like physical AI and the agents, and I feel like you're right. In the future, when you kind of have this physical workforce or robots, there's going to be like all these interesting applications of AI, and it is kind of worth thinking about and discussing now. So thanks so much for your time.
Thank you, Nathan. Thank you for having me.
Awesome. That was an amazing presentation by Yanika. I personally really enjoyed it. Um, Next up, We have Princey. Hey, Princey, it's nice to see you.
Hi, Nathan. Likewise.
So Princey, for some context, is a graduate student at Northeastern, specializing in information systems. She has a robust background in machine learning, and I mean, she'll tell you all about herself, but she'll be talking about a really interesting learning assistant agent, and I personally have really enjoyed learning about it, and I'm really excited for the talk.
Thank you, Nathan. I hope my screen is visible. Yeah. So, good morning, everyone. And I'm thrilled to be here to talk about how AI agents are reforming the way we learn and access information from the internet. My project, the Learning Assistant AI Agent, is one such response to the reformation that the AI agents are making. Before proceeding further, let me briefly introduce myself. I'm a graduate student at Northeastern University, and I'm particularly interested in leveraging AI to democratize knowledge and learn efficiently and effectively. This the motivation behind this project of the Learning Assistant AI agent stems from my desire to address the challenges that we face while starting to learn something new. In today's digital world, whenever we start learning about something new, we are faced with three key challenges. The first one being information deluge. In today's digital world, the sheer volume of information on the internet can be overwhelming. We are bombarded with information, and finding the right information can feel like looking for a needle in a haystack. Secondly, valuable resources are scattered. Whenever trying to learn about a new topic from scratch, it usually involves sifting through countless platforms like research databases, video sites, GitHub code repositories, blogs, etc. This fragmented this fragmentation of resources makes it incredibly time consuming. And the third key challenge that we face is the efficiency gap. Manually gathering and integrating this data can create a huge time sink. It pulls us away from the actual learning itself. AI agents are here to offer a powerful solution to these problems. My project, the Learning Assistant AI agent, acts like an intelligent assistant, streamlining the journey by integrating diverse resources into a single platform. It integrates resources like the research papers from the archive, blog posts, YouTube videos, GitHub repositories, etc. All the user has to do is input the topic they wish to learn about, and the agent will retrieve all these resources into a single platform. Let's take a look at the user interface of the assistant. Users simply have to choose between the model they wish to, between Gemini and OpenAI GPT-4. Input their API keys and simply input the topic they wish to learn about. The agent prompts five different options like overview of the topic, research papers, blog posts, or GitHub repositories, as well as YouTube videos. Upon selection, the agent queries relevant APIs and databases and displays results in a user friendly format. This agent was built by leveraging several tech technologies like the Agno framework, the Streamlit framework, and several APIs like the OpenAI API, Gemini API, GitHub API, Firecrawl API, and the Archive API. Agno is a open source framework. It is the core framework that powers this AI agent. It is open source and used for building multimodal AI agents. The second one, Streamlit, it is used for building user-friendly interfaces just by using Python. Leveraging these technologies, the agent is able to perform several core functionalities like generating overview using the DuckDuckGo and Google search. It is also able to retrieve relevant research papers from the archive using the archive tool. It also retrieves and recommends top GitHub repositories for practical coding examples. It curates a list of top blogs using the Firecrawler tool and presents the URLs and brief summaries about the blogs. And finally, the agent also suggests relevant YouTube videos based on the topic the user has input. Let's take a look at the agent in action. I have a video recorded for this. I don't know why am I not able to. Okay, yeah. The user can choose between the model, input the API keys, and simply type the topic they wish to learn about. Like here, I'm searching for LSTM with attention mechanism. The agent generates overview of the topic and presents the result in a streamlined manner. As you can see, it has presented several key information about the topic. The agent then searches for relevant research papers in the archive. The agent also summarizes the research papers and gives key findings in the results along with the author names, as you can see. It also provides a URL where you can access the complete research paper. Here's the research paper. You can view the PDF on the archive website itself. Then let's look for the blog post. The agent fetches the top blogs and provides a list of the blogs related to the topic that the user has input. As you can see, it has also provided a brief summary of the blog post. Here's the complete blog post. Now, the agent retrieves top GitHub repositories and sorts them based on the number of stars and forks of the repository. It also provides key features along with the information about the documentation, if it is basic or maybe good, excellent. As you can see, the agent has retrieved the GitHub repository here. Moving forward, the agent searches for educational videos related to the topic on YouTube. Eh, So that was the agent in action. I wanted to give a live demonstration, but because of some issue with my system, I'm not able to share my screen. Okay. I think now I can. Let me quickly move to the slide we were on. Let's take a look at the performance analysis of the agent. Testing has shown an average response time between 2 to 7 seconds. Upon testing, it was also seen that the agent was able to look for content that matched 92% of the search queries. The agent was also able to aggregate information from more than 5 distinct platforms. And 85% of the content that the agent retrieved was less than 6 months old. Future development of this AI agent will focus on expanding data sources. I plan on integrating more APIs and databases for content generation, like the PubMed for medical research and courses from Udemy and Coursera. I also plan on implementing a recommendation system that will suggest the resources based on users' past queries. I also plan on elevating the search precision with semantic understanding and customizable features, which will overall enhance the searching of the assistant. And finally, I plan on providing a feedback mechanism for the users to provide feedback on quality and relevance of the search results. Thank you for your time, and thank you, Nitin and Team Anote, for having me here.
Wow. Thanks so much for your presentation, Princey. I thought it was really, really exciting to learn about. I guess a question for you. If you had like a few takeaways that you would kind of say from building this agent, your learning assistant agent, like what would your kind of takeaways be, and how did you like enjoy building this?
Um, the key takeaways I would say were I I personally love where the AI technology is going. Um, I enjoyed building this project. Hello, am I not
Hello,
audible?
I can hear you.
Yeah, sorry about that. Yeah, so I personally enjoyed building this project. I learned about different frameworks that I used during building this assistant. And yeah, uh, I am using this agent for my everyday purposes, like whenever I'm trying to learn about something. So it is better than to go through all the resources one by one and look for information over there, and instead I'm just able to find everything on a single platform.
Well, that's amazing. Thanks so much for sharing this. We really appreciate it, and I personally learned a lot. So thank you.
Thank you for having me, Nathan.
Awesome. So that was an amazing presentation by Princey on like learning assistant agents and building agents, and I thought it was like really cool. Um, Next up, we have Shubham and Sid. I'll give a quick intro on them. So Sid is currently a master's student at Stevens, where he's exploring the intersection of deep learning and AI. He's done a lot of really interesting work on economics, and he's going to show a little bit about how PrepRight leveraged AI-powered skills assessment to tackle critical challenges for looking at kind of skills and enhancing your interview process to kind of get the skills you need for the job. He's working with Shubham, who's also an AI enthusiast and software engineer with 5 years of experience, currently pursuing his master's in AI at Stevens, who's worked in multi-agent reinforcement learning, game theory, and is passionate about real-world AI applications. And we'll also see today an amazing product demo of PrepRite, right?
Yeah, thank you, Nathan. Yeah, let me just share my screen. Okay, give me a minute. Entire screen is the Just let me know if you can see my screen.
Yeah, you should be all set.
Thank you. So yeah, good morning all. So this is Prep Right. So I just do the first introduction, right? Imagine you are applying for your dream job. You upload your resume, carefully tailor it to match your job description, and hit apply. But what happens next? You are one of the thousands of candidates competing for the same position, and only a same small percentage make it past screening process. Many talented individuals struggle not because they lack potential, but because they are adequately prepared. They are not adequately prepared for the technical assessment and interviews. Introducing PrepRite, an AI-powered platform designed to bridge the gap by assessing skills, providing targeted learning resources, and offering real-time interview simulations to help candidates succeed in hiring process. So I just mentioned you the what are the problem statements, right? The current job application process is highly competitive. More than 75% of resume never reach human recruiters due to ATS filtering, right? Even those who do get shortlisted often struggle with technical interviews, where only 20 to 30% of candidates advance to the next round. This is a clear disconnect between job requirements and candidate preparedness, leading to missed opportunities for both applicants and employers. Traditional learning methods are generic, time consuming, and do not adapt to individual weakness. Candidates need a structured, data driven, and personalized approach to a job preparation. And that's exactly what PrepRite offers. Yeah, so now what I will do, I will ask Siddharth to go. Oh, one moment. Give me a minute. I need to. Yeah.
Hey,
Mute.
Uh, Hi, am I audible? Or is the audio still looping?
it's good. I can hear you now. Okay.
Yeah, okay, cool. Shivam, can you share the slides again?
Yeah, sure. One moment.
Yeah. So about the product, right? We kept the process as simple as we could keep it. Um, You just upload the job resume that you have selected for the job and the job description. Next, the AI analyzes the uploaded data. It identifies the skill gaps and the mismatches in the resume, or the disconnect in the resume and the job description. The system compares the candidate existing skills with those needed for the job. It highlights the gaps where additional learning or experience is required. Then it gives an assessment on to decide how skilled you are in the current role. So it suggests questions based on the current resume and the job description. Based on the answers provided in the questions, the AI will now prepare a personalized preparation plan to help go through the interview. The plan focuses on high impact areas, basically the areas in which you currently lack for the interview. So rather than spending time on just broad learning and going through all the material, you get tailored recommendations, and this ensures that they concentrate on the skills that will make the most impact. The AI highlights the areas of improvement, focuses on the skills that are needed for the job readiness. Yeah, and next slide, please. Yeah. So we use React, Node.js, and CSS for the website part of the app. We use mainly Python and LangChain to support the backend and getting the recommendations. And finally, we use Gemini and OpenAI for generating the questions and generating the resume plan, then generating the interview plan. Yeah. So here's how the website, like the web app, looks currently. You just This is the assessment page where the questions are generated and we have to answer them. And based on the answers and the resume and the job description, you will get a personalized plan on seeing uh, on how ready you are for the interview, and identifies the high impact areas. We'll now go to the live demo after this. Thank you.
Okay. Yeah, can you hear me? Yes. Okay. I hope you can see my screen. I'll just this is prep right, and yeah. Uh, okay. Okay. So yeah. So I'll show you how the application works. Let me just first choose file. So I'll just choose my resume right here first, and the next is the job description. So it can be whatever the job description that you're looking for. You can look in from the LinkedIn as well. I have saved one job description already, but it can work with any job description that you choose. So I'll just go here, right? So I am applying for an AI engineer job, so that's what it is all. Just copy it. Yep, one moment. Okay, something is. Okay, here we go. I'll just paste it and I click on continue to skill assessments. Yeah. So now what is happening is that when you upload your resume and job description, so both of the things can be in any discipline. It's not only related to AI. It can be from HR department, it can be from any skills, right? So it covers end to end any job type, and from high end CEO job to any clerical job you can apply. So we are preparing for our summer internships, and we were thinking, yeah, why not just create uh, an AI application for us? Yes. So this is what we did. And now what we are able to do is that when we upload a resume, and the second thing is that when we upload a job description, what happens is that uh, when we click on it, then we are applying. Okay, wait a minute. So what is happening? Let me just check. Okay, here it is. So let me just do the start over here. Hmm. Is it due to sharing my screen? One moment. Okay, just give me a minute. I'm stop sharing and just maybe it might work. Okay, yeah, now it's working finally. So let me just share my screen again. Entire screen share. Okay, so here we are back, right? When I clicked on okay, then the skill assessment is here. So the main uh, target here is that we should be able to write all the answers that we have. You should know what you are talking about: binary classification, random forest, bias variance, right? Data data set significance, class imbalance, everything, right? You should know everything about if you are applying for that job. But for the time purpose, what I'll just do, suppose I'm a beginner, I don't know anything, and I want to learn how to bridge the gap. I'll just write no idea, not sure, right? Maybe bias variance, okay, trade-off, oh, I have heard about it, but I want to write something. But okay, let's just write not sure right now. Okay, you can write all the things that are required. I'll just click on continue. Now suppose I'm a beginner and I don't know anything. What I look for is the maybe 14 days are enough for me to write to generate yeah, to prepare for this application, for those that supposed job application, right? So what I'll do, I just click on submit and choose that 14 days plan. Now, what is happening is that now it is currently processing your resume and the job description and the answers that you have given, right, correctly. Now, what it will do, it will find the gap where you are. You include using your resume as well as your answers, and it will show the answers. It takes a minute for now because we are using cheap APIs currently. Yeah, now, but yes. So let give it a minute. I'll just show you the results that we have already created. Meanwhile, it is loading. Okay, it loaded. Nice, nice. So now what it is showing that, yeah, according to your resume you're an intermediate level, but according to your answers you are requiring a lot of um gap that we can found. And this is the we have prepared a full 14-day plan for you that are required for you to prepare for this. And if you see what is remaining, it goes day by day. You can click on any link, it will open it up for you what you need to learn about it, right? the be it lead code problems. It will show you what you need to learn about it, right? It will show you the problem set that you need to complete on that day, right? Maybe the system design you need to understand, that will be there. Yes, so that is all. Okay, let me just go back to the PPT now. I'm on mute. Okay, future scope. You can talk about.
Yeah, thank you, Shivam, for the demo. In the future, we have plans on like a real skill evaluation time in which there won't be a single. This won't be a single agent app. It will be a multi-agent process. It'll also we'll also planning to have a resume tailoring feature on the app, and we also have a plan to simulate like real world interview scenarios in which there may be an it's like an audio interview or maybe like a immediate technical interview based on the resume and the job application. Yeah.
Yep.
Awesome. Well, this is amazing, guys. Just wanted to say thanks so much for this presentation. Like, honestly, like I would probably use it sometimes. I'm really excited for your guys' kind of startup demo today in person in New York, where we'll see you guys live. So if anyone's really interested and wants to meet Sid and Shubham in person, roll through. It's going to be an amazing time. And thanks a bunch.
Thank you so much, Nathan.
Yeah,
Thank you for the opportunity.
yeah.
Thank you.
Awesome. So that was an amazing presentation by Sid and Shivam, like great students. Stevens is an amazing school. We work closely with them at Anote. Next up, we have an amazing speaker, Pinar. Pinar is a strategic AI manager at the Harvard Business Review, where she leverages her extensive experience with generative AI and agile methodologies to drive innovation and excellence. She's done an amazing work in her career, working at Conviva and at a new position soon TBD. She has an incredible educational background, including an MBA and advanced studies in AI. And she's going to give an amazing talk today about a strategic, comprehensive AI agent roadmap. So I'm personally very excited for this presentation. And Pinar, I'll let you kind of take it away.
Thank you so much. I think I'm already sharing my screen, right? Perfect. That's nice. And thank you so much for the opportunity. I'm truly excited about this. So thanks for the introduction as well. So let's start. So imagine a world where digital like assistants not only answer your questions, but proactively solve complex problems, optimize business processes, and learn from interactions to improve continuously. That world is already here, right? Powered by AI agents. Today, I will walk you through this fascinating journey of what AI agents are, why they matter, and how to strategically implement and scale them for success. I would love to start. What is an AI agent, right? So, at its core, an AI agent is a software program designed to interact with its environment, gather and process data, make decisions to achieve specific goals. These agents can operate autonomously or in collaboration with humans, which is incredible, and other agents as well. What makes them special is their ability to adapt, learn, and optimize the whole processes without constant human intervention, which is huge. So, key characteristic of AI agents. To truly understand their potential, let's look at their characteristics from autonomy, memory and learning, perception and decision making, tool utilization, and one of the most important is collaboration. These characteristics are the building blocks for scalable AI driven solutions. Uh, in my next slide, I would love to talk about the types of AI agents. Um, like simple reflex agent, an example is basic chatbots. Model-based reflex agents, an example is a customer service bot, which is really used where in various industries very efficiently right now. That was a like a big change for all the companies. And then goal-based agents like drones, utility-based agents like financial portfolio, which is again super critical. And why they matter, right? So they increase the efficiency gains, they automate routine tasks, scalability. As business grow, agents can scale the whole operations without proportional increase in manpower. And the other one is proactive decision making. They enable businesses to act on predictive analytics insights before issues arise. And the last one is personalization. Agents can tailor experiences and recommendation for customers and users. In a sense, they're redefining how businesses operate and interact with their ecosystems. I would love to jump into the how we can create efficient program for AI agents. Implementing AI agents strategically requires a clear roadmap. I will break this down into 5 phases, each with its unique objectives and deliverables. I would start with the foundation and planning. In any programs, the planning is really important. Sorry. The first phase is about setting the right foundation, define business objectives and potential use cases for AI agents, assemble a cross functional team with AI expertise, build a robust data infrastructure to support AI models. A strong foundation really helps to ensure that your AI agent programs are built on a scalable and sustainable framework. And the next one, I would love to talk about how we can start the pilot the program to make sure to increase the scalability and efficiency of the program. In this phase, we develop a minimum viable product MVP for AI agents focused on selected use cases like launch pilots to validate the agent's performance and the usability. The second one, establish ethical governance and monitoring the systems and gather feedback to iterate for improvement. Pilots are where you learn, adapt, and perfect the development process before scaling. And how we can scale, right? That's again super critical. Like once validated, it's time to scale. Rolling out AI agents to additional business units other than the pilot one, and understanding the use cases, collecting the use cases, mapping them with the business outcomes. Integrate AI agents with core systems like CRM, ERP, provide training internally and also externally with the clients, establish feedback loops, really critical to improve the overall programs and to drive adoption. Scaling effectively transforms AI agents from a concept into a core operational tool. And the next one, how we can optimize and innovate. So this phase focused on continuous improvement based on the pilot programs, and after the scaling, it's really important doing fine-tuned models for accuracy and efficiency, enable proactive intelligence through predictive analytics, and then testing, adopting emerging technologies such as generative AI, edge AI, like this phase, like optimization and innovation, ensure that AI agents stay at the cutting edge of the technology is really important. And then the next stage, the last one is full maturity, how we can create a full maturity. And I also would love to talk about the key success factors. AI agents become and embedded in your organization's DNA at this point. Continuous performance monitoring and governance remain essential. Success depends on three key factors. Stakeholder alignment is really important. Robust AI governance, again, super important. And a culture of continuous innovation. Organizations that reach this stage unlock long term competitive advantages. And I would love to end my slides talking about how to make sure we are ready to implement AI agents roadmap. AI agents are not just futuristic ideas, they're here, right? Reshaping industries. As engineers, entrepreneurs, AI enthusiasts, we have the power to harness this transformative technology. The key is strategic planning, disciplined execution, and commitment to innovation. So, this is the end of my presentation, but I would love to hear if you have any question for me.
Wow. Thanks so much, Pinar. This was like an amazing talk. I feel like AI agents are obviously going to become one of the most core and essential technologies in the next 2 to 3 years, maybe even the next year or two. I guess, if you kind of could give advice to kind of different companies that are looking to implement AI agents in production and like some strategic guidance, what kind of advice would you share? And where do you think kind of things are going from here?
That's a great question. Uh, like the creating a team, like the human interaction is super important. I don't see the future without human, and we should be able to train the our employees very well to get ready for the future with a growth mindset and continuous learning and feedback loop. And I see in different areas, but always happy to learn, always to improve the overall processes, also very critical. And like getting the feedback, learning from the feedback is very important, and I think it should be open to everyone to see. That's how I see the future, basically.
Very exciting. I completely agree. It should be open to everyone, and it's kind of up to us to kind of come together and think about how we can build these best systems to make it most impactful.
Yeah, that kind of brings the collaborative competitiveness, right? So, and I think that's the new way of growth for any industries, any technology. So that's how that's the key. So
Awesome.
thanks again so much for the opportunity. uh, I'm so happy to be part of this.
Thanks so much for joining. We really appreciate it, Pinar, and thanks for your time.
Of course.
Wow, that was amazing talk by Pinar. I really enjoyed it. Next up, we have a very special speaker. Hey, Chuckson.
Hello, can you hear me?
Yeah, I can hear you. So I guess, yeah, a little bit about Chuckson. Chuckson is a data scientist at JP Morgan Chase. She specializes in quantitative modeling and risk management. She's also really involved with the AI camp community in New York City, and I've kind of been to a few of their events, and it's been remarkable to see what they've done. She has an awesome background in economics. She has experience in time series forecasting and data science. And she's going to be giving an amazing talk today about a data analyst AI agent. I'm personally really looking forward to it. And it's great to have you here.
Thank you. I'm really honored to be here. Let me share my screen. Okay, so my talk is about data analysis AI agents. So I really appreciate the previous speaker introduced the AI agents for the audience, and the opinions on my own and does not represent my company. So the talk will talk a little bit about how I think about building AI agents for data analysis, which is fundamentally a very complex task. I compared a few frameworks that I tried. Due to time limit, I can't go into agentic IDE, but I will also share some takeaways from this learning journey. Nathan gave a very great introduction about myself. So I'm going to skip this as well. The first part is thinking about how we can create an AI agents for data analysis. And so I would like to invite everyone to think about a thought experiment. So let's pretend that you are a manager for a moment, except that you're already a manager. And you want to assign tasks for your AI agents to do data analysis. So then your question is, what kind of skills and tools does your data agent require? And I think these are some of the very important ones. The first three are understanding, reasoning, and planning, and coding. Coding is also very important. And then the fourth to the sixth ones are a little bit different from the first three, which can rely on large language model alone. So those are where an agentic framework comes in. So for example, tool usage, such as function calling, code execution, code debugging as well. And then think about memory. You need places to store your codes, and you need place to store your analysis results, your visualizations, and you need place to put your report. Last part, I think, is also super crucial in data analysis. That is the human input. I think that the last part is where it sets a human data scientist away from a AI data scientist, where you really understand your business, your data, and understand risk and challenges, where you can guide agents to do deep analysis for actionable insights. So yeah, the first three, as I said, large language model can do it. For reasoning and planning, you probably want a smarter large language model like the DeepSeek or the O1. And then for understanding and coding, if it's easier, you might go to a smaller and cheaper model. And then for the second half of the abilities or tools, this is where I think some frameworks and or the agentic IDEs really help me through this learning journey. So I'm gonna this talk I'm gonna focus on the different frameworks that I have tried and how I think about their pros and cons. So let's get started with a very simple example. If you're a data person in a business team, you probably get a lot of ad hoc requests about your data. And they say, oh, just run this for me. So I came across this framework from Lang Chang. It is very simple and easy to get started with. Basically, you have a data frame. Let's say it is the Titanic data, and you have a request or your prompt or your task that is how does survival rate correlate with gender and age. And so basically you create an agent that's very out of the box that you can use, that this agent answers any questions related to this data frame or a list of data frames. And then you can just simply invoke this agent with your task. And so the agent goes in, think about what to do, write the code, and run into bugs. And then it debug itself, run the analysis again, get the results, and come back to me, even with an interpretation of the correlation analysis. So then for people who don't understand, let's say, strong correlation or weak correlation, this is then this communication is very effective. So yeah, this is very simple to use. I liked it. I think this is a tool that I can just throw my data frames in and just ask any questions I want. And I can ask that question anytime I want. And then in today's conference, I assume that many people would talk about multi-agent systems. So I'm not going to go into what is a multi-agent system, but basically you can have more than one agent. You can have agents that are good at different things. So I think Crew AI, when I tried it, it gives me a very clear guidelines on how to build a multi-agent system. So basically you can have different agents that are good at different things. Let's say one is good at coding, and this one needs to have a tool that is code execution or code interpreter. And then you can have another agent that is very good at communicating, that communicate the results of your findings. And then below that, you have tasks where you really need to think about what your day-to-day work as a quantitative analyst or a data scientist is, and break it down and articulate it really well so that your agents will be able to do it as in your desired way. And then at the end, you group them as a crew. So here is an example. So the first agent I have is a coding agent. It can write Python, it can run Python, and it has a tool that is the code interpreter. The task I give this agent will be just a simple exploratory data analysis task. And I also specify that I want the agent to give me a JSON format output as the results of this exploratory data analysis. I can have another agent and another task that focus on communicating. So this agent is a data interpreter, and the task for this agent would be to communicate the results of the exploratory data analysis and also suggest what is the next step. So we have two agents, two tasks. This can be our simplest crew. We group them together, and then we can just pass in our inputs, the data frame, and then we just kick off this crew. And here is the results. So the first agent runs the analysis and give me these JSON formatted results for the EDA. This is not something to show to the business stakeholders. So the second agent goes on and analyze it and provide the communication. So this data is about the New York City car accidents, and it's able to understand what this data is. That is a success. And then it's also able to suggest further analysis after that. So then after that, you can build more agents or more tasks into your crew. Okay, so then we forget that there's human input, right? So we, in general, when you work with data, there are a lot of moments you want to step in and do deeper analysis to really understand if your data is valid, if your approach is correct, or if you are really zooming into the core insights of your business. So there can be a lot of different reasons, and this is where you are smarter than an AI. And I think the AutoGen framework really helps me think about incorporating that. So AutoGen framework think about agents collaboration when they chat with each other. So you can imagine that the agents they chat with each other and they're good at different things, and they submit their results to each other, and at the end they're done. So in this case, the human input comes from a user proxy agent. I feel it very funny because the user proxy agent is actually the one the one that is you. It is the one that takes your input. So the user proxy agent is representing you and will pass in your feedback in the middle of the task or in the middle of the work. And in the tutorial that they have on their website, the user proxy agent also executes the code. I think it doesn't necessarily needs to be that. So you can have one more agent that executes the code. I believe that is okay. And then you have the assistant agent, which is the agents, the AI agents. This agent writes code for you to do your data analysis. So then it's a little bit different from Crew AI, but it has similarities. Basically, you have one overall task. Let's say do data exploratory analysis, and then you have two agents. One represents you as the human input, and the other one write code, and then one of them execute the code. So then you can have one chat that put them together and start working. And then you initiate a chat. Another thing that I found really interesting is all these different frameworks have different verbs. So for example, in LangChain, it is invoke. For Crew AI, it is kick off, and this one is initiate chat, which I really, really find it funny because I feel that coding has become more and more like a human language. I'm not going to go into details of the results, but for example, here is one example where I added my human input. For example, the agent printed out summary statistics, but some variables are hidden because of the print function. So then I say, oh, when you print summary statistics, you hide some variables. And so then the agent is able to fix the code and rerun and was able to see all the other variables as well. Because of time limit, I can't talk about agentic IDE, but I made a video on my YouTube about how to use Cursor to do EDA. So yeah. Finally, takeaways. The first thing is we have different framework, but you want to be framework agnostic. You want to focus on your usages and your tools. And think about all these abilities that I mentioned before, which one is more important to you. And then the other part is a reflection on our job, which is a craft, and those are the part that is not replaceable by AI. And I think very positively about that. Okay, I finished on time. Thank you. I will be there tonight at the event, and some QR codes for my contacts.
Very, very cool. I'm also kind of curious about your agentic IDE and Cursor. Can you share like a little bit about that? Yeah.
Oh, so that one is not. So that one is very simple. Basically, you, as a data scientist, you just pretend you're a software developer, and then you develop a software to do EDA, and then you ask the agent to put all the results in a markdown file. That one is not as so then it's a different kind of workflow, I think.
Very, very cool. Yeah, it's definitely all check out these QR codes. I personally thought this was like an amazing talk. So
Thank you.
thank you so much. Yeah.
Okay, I'll see you this evening.
See you this evening.
Have a good day. Bye.
Bye. Awesome. That's like a fabulous talk by Chuckson. I thought it was like really cool to learn about all the different agentic AI frameworks, and I'll definitely actually hit her up after this to learn about her agentic IDE with Cursor for EDA. That sounds like really cool also. So next up, we have, I believe it's Thomas from Backflow. He's here. So,
Hi, Natan.
hey, it's great to see you. Yeah.
Great to see you as well.
So Thomas and I have actually been good friends for a while. He's built this really incredible company called Backflow. Does a lot of agentic RAG for the legal sector, I believe. Studied computer science and math at Columbia. Has done a lot of research assistantships, and his kind of company Backflow is one of the most exciting early stage startups today in the AI space. I'm really excited to see what kind of happens next. And without further ado, I'll let Thomas take it away.
Sounds good. First, thanks, Natan, for hosting all of this, and thanks, Chushin, for all of your work on agentic frameworks and presenting that. I definitely very much enjoyed that, and I will definitely have to hit you up afterwards as well. So I can share my screen. Perfect, thank you. I'm going to be talking today about Vecflow, right? So we are a legal AI platform, primarily for document review, drafting, and analysis. We work with law firms across the entire world at this point, some in North America, some in Europe, and some in Asia at this point. And I am their co-founder and CTO. And one of the things that we're really interested in is drafting, right? So this talk is going to be primarily on drafting. So we'll go overview of what we do, how the drafting flow works. We'll roll into a short demo, and then we'll talk about why drafting is hard, what the problem is here, and then how it works and how we are improving it as well. So without further ado, one of the things that we really focus on at Vecflow is one-click workflows. So these are, rather than chatting with something, right? We want to help a lawyer do a particular task with a dedicated workflow for that particular task. So we have workflows for chronology generation, for instance. That's if you have like thousands of pages of documents and you want to generate a chronology about how a particular client or plaintiff worked, that would be how you would do that. We also have like redline analysis. So that's like if you have a document that's been edited, you want to know how to summarize that document and what edits have been applied and what edits raise red flags, for instance. And this is all in the legal context. And of course, I worked previously at a very small law firm as well, and then I did some ML research at Columbia. But for this presentation, we'll focus on two things. One is drafting of clauses, and the second is drafting of end-to-end documents. Both of these are actually very challenging tasks, and both of these are used by lawyers across different practice areas. But primarily, the lawyers that we will be focusing on are lawyers who draft contracts. So this could be for mergers and acquisitions. This could be for like vendor agreements for companies. It could be for venture capital, for instance. All of these different practice areas and all these different lawyers, at the end of the day, their work product is a document that they send to a client. So that's a little bit of the context here. And we've thought about this flow as being we've thought about this as how do you build a flow that does this accomplish for a user, right? I'm not sure how agentic it is, but at least it uses large language models, has a framework on top of them, and then is able to get user feedback. And so, for instance, a lawyer, whenever they are doing a particular task, whenever they're drafting a document, they use a prior precedent document and then they edit it with supporting documents. So that's the base document. The precedent document is your base document. The supporting documents are could be a term sheet, it could be a client email, it could be a transcript, it could be whatever type of information that you want. And then you also have external information. So that could be the internet, possibly, case law, possibly, and then something called SEC Edgar, which is the place where companies put their public filings. And the benefit of SEC Edgar over Google and case law is that it has particular clauses that lawyers would draft. So for instance, if you are drafting a merger agreement between two different companies, you want a termination clause. And that termination clause specifies the terms that one party or another party could terminate the agreement. And a lot of these clauses are either in precedent documents, that means in like a lawyer in a law firm's knowledge base, or they are part of part of SEC Edgar. So those are kind of the sources of information here on the left. We then generate a plan, right, of how we are going to edit the document, what type of information we have, and we sometimes go back to external information if we need to pull more information. And then we also incorporate user feedback. That's from the lawyer, right? And so after you do the plan, a lawyer is able to review the plan as well. And then we also are able to build a first draft at the end of the day. That's the next step there, once we verify the plan and add a little bit more information. But this is all at a very high level, right? I think it would be great to see a little bit how it works, right? And this is all in the context of like trying to apply these large language models on a day-to-day basis in a lawyer's workflow. So if I, in our application, I can click New Draft, and then I first want to select or upload my base documents. That's the document that I want to edit. This could be, in many people's context, maybe an essay they wrote or something like that. And so if you select their service agreement, so first, let me go over which documents we are doing right now, right? So we are going to try to edit our own service agreement which has recitals at the beginning. It has some defined terms like that. It has various different clauses controlling various different applications of our application, right? So it contains limitations of liability. It contains term and termination of our agreement. It contains a publicity clause. It also contains some notices as well. And it also contains an exhibit. So this is the signing where people sign, and then this is the exhibit at the end, which goes over the specific like start dates in terms of our engagement with our clients. And then we have a playbook. So this is like how a lawyer would review a document. It says for particular clauses, any guidelines that a lawyer would apply for a particular clause. And so, for instance, for the publicity clause, we're going to focus on the publicity clause here. It says the provider has no automatic right to use the client's name, logo, or testimonials. And if you look at our contract, our service agreement, it does have a publicity clause. So this would not pass a playbook from a particular law firm. We also have an email from a given client that specifies what the certain features of this contract and this engagement should look like. And so a goal, right, is to edit this service agreement, create a first draft of this service agreement that incorporates all of the details from the playbook and from the email. And so in this case, of course, we selected as a base document that service agreement. And then as reference documents, we will select the playbook as well as the contract. So let's select the playbook as well as the email. Apologies. And then we can put in some general comments. So the general comments we are going to apply says you are reviewing and inserting information into a contract. The date should be February 9th. Let's change that to February 11th, I believe it is. And then the total contract size is 100,000. So that's an annual contract size. And then we're going to say use this playbook and then use this email. And then I'm going to click next. And now it's generating a plan. So this plan it looks over all of the information. It also tries to do a Google search for any information that it needs to look at, right? And then it generates a plan for how it's going to edit the document. And this is crucial because there's a lot of ambiguities in a particular document. So for instance, I did not specify whether or not the annual fee is paid upfront or split into installments. So I'm going to specify that it's full upfront. And then I'm also going to specify that the company's address should be inserted. And then the limitations of liability cap is exactly 1 million there. And then I'm going to click save, and then I can see the plan, how it's going to edit the document, and an overview, as well as the answers to the follow-up questions. And then you can always edit the answers. I'm going to click review, and then you can edit the prompt and how it's and the entire thing about this. So I can edit this and say, I don't want to use this, I do want to use that, etc. Right? So I can save changes, and then I'm going to click submit. And then this is in the drafting process there. While that is going on, we can look at a kind of a previous version of this. So I think if I go right here, we can see that it's able to edit the document very precisely, right? So insert the date, insert the name of the company, insert the address, and it's also able to edit particular clauses, again, in a very precise manner. And it's able to delete the publicity clause as well, because the publicity clause does not satisfy the playbook. So I know that is a very detailed example, but just a little bit about how this process works. I'm going to go back to the slide deck here, and we can roll through a little bit about how this is challenging. So in the particular case I used, right, we kind of had too much information in many cases, right? So many legal documents are not templated, and often there's additional specific line information that you're given that isn't needed later on. Legal documents are also highly context dependent. Like code, legal documents, if you change one piece of them, you can change the entire thing. But unlike code, you can't run a legal document. You can't test a legal document, right? So there's no way to verify whether or not you did it correctly or not. And then there's a time versus quality aspect. The more time that you spend on the particular document, the better it's going to be. But on the other hand, the more time you spend, the less human in the loop you can get. And finally, Word documents are notoriously hard to deal with and can be extremely challenging to edit, partly because there is no precise mapping between XML, the underlying document format of docx files, and text. So those are some of the things that are hard about this. To solve the first issue, the ambiguous information, we try to corroborate as much information as possible between these documents. So we look at both the supporting documents and the base documents and some external information. And of course, we try to ask the lawyer directly if there are any ambiguities. And to solve the sort of context-dependent issue, we do clause-level drafting, which we also sell as a separate product. So we draft each clause directly, and then we consolidate up the information. And that's the next step, right? We can consolidate up the information between different clauses by using an LLM directly to, once you have the changes for each clause, you look and see, are there any overlapping issues? And are there any like things that one thing changes that then you have to change later on? And this means that we can very precisely edit a underlying Word document in ways that even a lawyer would have trouble doing during the time allotted. And I think that the final thing I have to say is I think we have internally benchmarked our product against a lawyer's work, comparing the two side by side. And we see that sometimes we actually outperform the lawyer on certain drafting tasks. So I think that's very exciting. And I think that we are very excited to launch this product to lawyers around the world. Finally, thank you guys so much. And thank you, Natan, for hosting this event. Feel free to reach out to anyone. I think we're always looking to hire people, both on the law side, but also on the engineering side. So my email is thomas@vecflow.ai. Feel free to reach out. Thank you.
Wow, what a remarkable presentation. That was really amazing. I personally enjoyed it and just want to personally thank you for taking the time to kind of speak at this event today. So
thank you.
Awesome. Wow, what an incredible talk by Thomas introducing Vecflow. I personally learned a lot. And, honestly, if I was a lawyer or in the legal space, I probably would use that product like yesterday. Uh, so next, we have Jiten. Hi, Jiten.
Hello, Nathan. How are you?
I'm doing really well. How are you?
I'm good.
So, yeah, Jiten essentially is a machine learning engineer who's also a student at the University of Maryland. That's correct.
Yeah,
And has really built a really incredible personal AI agent. I kind of first came across it when looking at different AI agent tools, and I thought it was one of like the most interesting examples I saw out there. So invited him to kind of give an amazing talk today, and see how it goes. Yeah.
yeah. So hello everybody. Myself Jitin Balawat. As Nathan has introduced me, I am doing my masters at University of Maryland College Park, doing my masters in applied machine learning. And today I'm going to tell you about my personal AI agent. So let me tell you, let's suppose my name is Jitin, right? So if I ask my AI agent that who is Jitin Balawat, what are his skills, where his experience he has worked in, and what are the certificates. So my AI agent should know all the information about myself. So do you think like it's possible that your agent should have all those information about you and he can answer all your questions? Right now it's quite possible because you can use your AI agent to get your all those document, all those your information, right? So now if you let's suppose your AI agent should know your information. So what are the informations your AI agent should know? Let's suppose it tells about your at which university you are studying. It tells about your skills. It tells about your experience. It tells about your projects. It tells about your certifications. It tells about your volunteer activities. Everything, right? So to get your AI agent, you should provide him all those information dynamically, and it will fetch your information from everywhere, either from LinkedIn, GitHub, your Medium blogs, your portfolios, your Insta profile, each and everything, and it will take all those information from all those different websites, and it will create an their own model agent, and then it will provide us the answer. So if let's start with how you can create your personal AI agent, right? So let's go to the next. So let's suppose if you're creating an agent, so your AI agent should know what the things you should provide. Your AI agent first should do a research, right? Let's suppose if you're asking any questions about your coding, or if you're asking about questions about your PhD thesis. So first of all, it will do a research about, okay, what are the questions you're asking and what are the role which you have provided to it. So it will do a quite good research, and then it will do an analysis, and then it will do a summary, and then it will provide you the output in the different formats like you want, in the form of JSON format, markdown, PDF, so that you can give this information to your another data, and then you can provide a whole automation process, right? So yeah. So there are different frameworks available. I will also share my screen and I will teach you like how you can create your own AI agent using all those different tools. So there are mainly four tools available like 3UI, LangGraph, PyData, and Relevance AI. So what you can do over is you can go over on PyData. You can go on tools and you can see there are so many tools available. And I will just show you as of now as well. Yeah, I guess you can see my screen, right? Yeah. So if you open the Phi data website, you can see there. If you go on the documentation and then you can go on the toolkits, you can see many different agents are available. So let's suppose not just your personal AI agent, but you want to create your something different agent, like you want to create some mathematical AI agent. So you need a calculator. So you can just use this calculator AI agent. Now let's suppose you have your own portfolio. I have my own blogs, right? I have my own blog, so I want to fetch all those informations from that, like how many likes I got, how many views I got, each and everything. So I can use this crawl for AI so that I can scrape everything from the data and I can get the information. Now let's suppose if your profile is so strong that you, if you search your name on the website on the Google, you get your all the information. So DuckDuckGo is there so that it will search what are the query, it will search on the internet and it will gather all those informations, right? Now let's suppose you are getting hundreds of email each and every day and you don't want to like check each and every email, and you have to respond it, right? So what you can do is you can use create your email agent where you can provide your ID, your password. See, you can see over here in the example section that you can provide the receiver email, sender name, and sender passkey, and then without even looking at, you don't even have to look at your email. It will just uh, your AI agent will check your email. It will provide us a response, and then it will send it by itself as well, right? So this is how the power of AI agent works. Now let's suppose if you want to provide a rag-based solution and you want to use your files. So like to create a rag-based, you need your files so that you can interact with them. So you can also use your file agent. You want to get your repositories, like you have created all your projects, you have put all your information on the GitHub, and you want to fetch all those information, so you can use this GitHub as well, right? So there are many other tools available which you can use to create a AI agent where it will search each and everything, right? Just, yeah, yeah, just a second. Yeah. So now if you want to create your own AI agent, like it tells about all your information. So what are the data sources you will provide it? Let's suppose you have your technical skills or projects in the GitHub. So you can provide your GitHub agent. Then second thing, you have your education and experience in the LinkedIn profile. So you can create your LinkedIn agent. Now let's suppose you're having your own portfolio, you're having your own Medium blog, so you have your own newsletter. So you can also create your Medium agent through which you can scrape all those data from your portfolio, websites, and anything, and then you can use as that medium agent. Now the fourth agent is, let's suppose if you ask any question about yourself on the Google, and it provides all those information, because that means that your profile is very good. So you can also fetch all those information, so you can create a general agent as well. And the fifth agent will be a team up of all the four agents. So the let's suppose there are four agents, agent A, agent B, agent C, and agent D. Now you want to mix all those agents, and then you have to provide us the output, right? So the fifth agent will be a team of all those four agents, and then we have to provide the role. We have to provide the role of the fifth agent, that you have to work as a team, and then you will get an output as a whole team. So now if I ask you a question about who is Jitin Balawat, so it will use all those things, like it will fetch from GitHub, it will fetch from LinkedIn, it will fetch from your DuckDuckGo, like using your Google site, and it will also search from my Medium docs as well. And then it will provide me that, okay, Jitin Balawat is a student studying at the University of Maryland College Park doing masters. That this information will get fetched from where? It will fetch from the LinkedIn, because I have updated my education profile over there. Now, if I ask about like where we in which companies Jitin work, so it will also fetch from the LinkedIn. Okay, yeah, Jitin have work in the XYZ company for the X number of years. Now, if I ask about, okay, what are the projects Jitin is working on, and what are the projects Jitin has already created in the past, so it will go on the GitHub and it will fetch all those your repositories, and it will also tell you that how many stars you have, how many uh, fork has been done. Everything has been provided by the GitHub, right? So it will tell about, okay, Jitin has almost 10 repositories. It teaches you about LLMs, AI, RAGs, chatbot, and each and everything. So it will provide you information about that. Now let's suppose if I ask, like let's suppose I write a blog, right, on Medium. So if I ask, okay, like what are the blogs Jitin writes each and every day, or what are the blogs Jitin has wrote in the past, or 1 month. So it will now use your Medium agent, and it will fetch all those informations from the Medium account, and then it will give you all those information. So it's like you are just sitting over here, and you are just asking your AI agent about yourself, each and everything, and your AI agent dynamically searches each and every website. It scraps everything. It scraps each and every information from LinkedIn, GitHub, everything, and then it gives you about your information. So not it's not static, that let's suppose if you after a month you change your information, so the AI agent won't be able to do it. No, that's wrong. it's dynamically. So like after, even after a couple of months or even after a couple of years, when you change your information on the GitHub, your LinkedIn, anything, and then when you ask again a question about your like self, like who's Jitin Balawat, so it will search dynamically, it will get all those new information as well, and then it will provide you with the very latest information. So that's the power of how AI agent works, right? So that's what I have mentioned over here. What your GitHub agent should do. The second one is uh, LinkedIn agent. The third one is your Medium agent, and the fourth one will be a general agent. So now how it works, right? So we have agents, we have tasks. So we can provide one agent a single task, or we can also provide one agent a multiple task. Now, like uh, when you want to send your whole AI agent into a production, so uh, you have to make so many things in the mind, right? So like you want to check about your memory, you want to check it doesn't hallucinate, you want that, okay, when I ask you about any questions again and again, so it gets stored into your cache memory, and it not every time searches the websites, it searches from the cache memory, and then it provides you the answer. So there are a few things you have to keep in mind about your quadrants, which tells about your model does not hallucinate. It has been testing, training, memory, so that it doesn't take each and every time more search, so that whatever the memories are stored earlier, it will can just store it, right? So let's, yeah, these are the same things. You can use different LLM models. Let's suppose now you want a reasoning, you are creating such an agent which requires reasoning type, so you can use DeepSeek Arvin reasoning model. Now you want that, okay, this task is such a very is very less, it does not need any much good LLM model, so you can just use a very base LLM models, right? So you can use different LLMs, and you on the different AI agents. So let's suppose you are having four agents, you can use all four different LLMs into it, and then in the fifth agent, when you create a team up, you can also use a different LLM model over it. So I will also show you like how your code works, or how your AI agent will work. It's the same thing. Yeah, I just shown you about the whole file data. There is also a crew AI where you can it is having also similar toolkits where you can provide different tools and different scenarios. Now let me show you the whole demo, like how it works. The second thing what you can do over here is what I have done. I have used an text to speech model. So what it does is, like, you got your information, but your information will be get in the terminal bar, but right. So it's no use because it's also text, and your resume is also text. So why do, if I want to just read the text, why would I just ignore the resume, right? So it's both the same. So what I have used here is, or what you can also use is, you can use OpenAI text to speech model. So what it does is, let's suppose when you got the answer, so it will convert the text into a speech. So let's see how it works. Okay, I guess it's a video, so I can't play it, but okay, yeah, I can just share my screen. Okay, I guess I don't have much time to go, so yeah, that's it. How my personal AI agent works. Thank you.
Wow, that's like an amazing presentation. I feel like there's a lot here. I guess if you can kind of give like a TLDR overview of everything, how would you describe it, like really simply? Yeah.
Yeah, so like, let's suppose if you have a crazy idea, you just break it out into a different parts. You break it out into a different AI agents. So your one agent can do a simple task, one second agent can do a multiple task, and then you created an agent which acts as a team, and it handles all other agents as well. And then you ask any question to the team, it will do all the task about yourself. Yeah.
Wow, that's super cool. So I guess if you had any like next steps here, what do you think you'd kind of build to make this personal agent to be like even better? What do you say?
Yeah. So next step, what you can do, or anyone can do over is, they can create your own AI avatar. So like if anyone asks about, okay, who is Jitin Balad, so your AI avatar will speak via from yourself, and not the text to speech model. So text to speech model, it will just provide you an audio, but if it's an AI avatar, it will there will also be your avatar of yourself, and it will speak. So it will just feel like, okay, I'm talking to a virtual Jiten. So it will provide you like AR VR experience.
Wow. Very, very cool.
Yeah.
Honestly, that was an amazing presentation. Thanks so much for your time. I personally learned a lot and it was really enjoyable. So yeah.
Yeah. Thank you. I hope everyone learned it.
Amazing. So that was a fabulous presentation. Next up, we have Faraz.
Hi, everyone. Can you guys hear me all right?
Yeah, I can hear you. So Faraz and I, we've actually been friends for a while. I think it's been 5 years now. He works as a software engineer at Microsoft, but he's actually also has like a lot of AI experience, including co-founding his like previous company Hatch, which is like an AI recruitment company. He's done a lot of really incredible things with LLMs and building, and he's built like this really awesome AI voice agent for recipes as well that I'm excited to see. And it's kind of been amazing to see his career progress from when we first met to today. And yeah, I'll let you take it from here.
Thanks, Natan. Yeah. Can you see my screen all right? Cool. So yeah, like Natan was saying, we've known each other for quite a while. And before I was working on another company, an AI agent company for recruiting. Actually, I was here at the last AI Anote AI Day, and I was presenting on what I thought was going to be the future, which was, we were back talking about chatbots back then. I was talking about agents, and it seemed like the predictions luckily worked out pretty well. So I'm here to make another prediction where I think the space is going into next, which is agentic evaluation, and specifically for voice. So yeah, like Natan was saying, I was working on an AI agent for restaurants, just building an AI agent that can answer phone calls, place orders, take reservations, answer general questions. But it turns out that it really sucked. It was it was high latency. It was hallucinating all the time. So my co-founder and I, we actually built an evaluation framework to test this agent. And when we were talking to our voice agent developer friends, they were more excited about the actual evaluation framework than our idea itself. So we switched. And as of a couple of weeks ago, we've been just working on an MVP for what we'd like to call Blue Jay. So yeah, let's talk about real-time agentic evaluation for voice. Before that, a little bit about myself. I was a undergrad and master's at UIUC, where I studied computer science, worked in LLMs. I did research in the LLM space, specifically around context compression for LLMs. This was just around when RAG was becoming popularized as well. And then after that, I moved to Microsoft, where I'm working on Azure Copilot, building out voice agents for the dev infra space, basically using Azure resources with natural language. And it's really exciting stuff. So now I'm working on Blue Jay just as a side project with one of my friends from Seattle. His name is Rohan, and he's also a co-founder. And yeah, together we built this MVP for you. So I'm excited to show you guys what's going on and talk generally about the agentic evaluation space specifically for voice. So before we get into what agentic evaluation is, or I guess how we do it, let's talk about the need, right? So agentic evaluation is all about trying to figure out whether we can find ways to know when an agent is doing something incorrectly, right? To basically know what's going on with an agent. And of course, there's the classic example when you're building fast of why do we need agentic evaluation, right? We can run the whole thing end to end. We can, run our front end and ping it, see what happens, or, have our agent call someone. And if we deem it fine, then what's the real problem here, right? But the issue with, foregoing agentic evaluation in specific as compared to foregoing regular test suites when you're building really fast is that with regular test suites, when you're working with non-LLM code, you have this degree of determinism between development and production, right? Like, yeah, it's always better idea to have a test, but if you were building something in development and you tested it thoroughly enough, then you can expect it to kind of work in production because nothing's changing. But when you throw in LLMs into the mix, you add a lot of non-determinism, right? Where you have behaviors that start to emerge in production environments that are a result of the fact that the models are actually outputting different information. So that's why evaluation becomes all the more important when you're working with LLMs, specifically with LLMs that are interacting live for example, voice agents. So you can imagine the use case of a restaurant that builds a voice agent to handle their phone calls, like their orders or their reservations, or in the sales industry where you're building a voice agent to kind of make cold calls or try to convert a customer to a demo, or in the customer service industry where you're trying to answer a question that a user has, maybe facilitate a return or get to the root cause of a problem, right? So there's many use cases here. But yeah, let's talk about what the need is besides just making sure that your production environment is steady. You also want to make sure that your tool call decisions are being accurately validated. So this is the idea of, when your agent is calling an external tool, you want to make sure that it is in fact calling the tool that you wanted it to, given a certain scenario. You also want to determine the agent's faithfulness, which is all about making sure that it adheres to its RAG setup. This is different from hallucination in the sense that it can still tell the truth, but maybe it's something that's not inside your RAG code base, your essentially your vector store. So faithfulness is a really important metric here to think about. And you also want to pinpoint instances of redundancy and hallucination. Redundancy is the fact where an agent would say something again and again and again without adding any extra value, or maybe go back into a loop. This is actually very common in voice agents when, for example, they're asking a customer what to order, and the customer states their order, and then in a couple seconds, the agent says, "Oh, can you tell me what to order?" again, as if it didn't hear it in the first place. So redundancy is a really frustrating user experience. So we want to cut that down, pinpoint it, and same thing with hallucination, right? And going back to the restaurant example, right? If an agent goes and says, if a user says, "Hey, can I order a cheeseburger?" to a dessert restaurant, and the dessert restaurant voice agent's like, "Yeah, sounds good. I'm going to text you an order link." That would be a big problem because now the voice agent, which represents the restaurant, has just lied to the user. So we don't want to have that as well. And the final thing here is that we also want to figure out real-time customer usage patterns. It could be the case that developers thought that maybe one pathway through their voice agent was going to be used a lot, but it turns out that like maybe 65% of users are actually using a different pathway. So if so, they maybe want to make that pathway a little bit more robust. So having that visualization and understanding of what's going on, how the users are interacting with their chatbots in a production environment is really important. So that's why we should use evaluation. Now let's talk about how we could do this. So there's four kind of ways here, and I'm going to go a bit faster because I want to go through this demo. But you can track custom metrics regarding conversational pathways, and this is just the idea of going beyond tracking the standard stuff like words per minute of your bot or latency or stuff that's very static, stuff that you can do almost numerically. I'm talking about more custom metrics, like asking questions regarding success of a phone call, depending on what success means for your industry. So that could mean something like, "Hey, did my order get placed correctly?" Or, "Hey, at what point in my sales call did I lose the customer?" So stuff that's a lot harder to figure out in a more qualitative manner, something that we can rely on the cognition of our agents to handle. We also want to identify cyclic pathways to reduce redundancy. And you also want to try to do heartbeat metrics. And the way you could do this is you can have simulated agents calling your production environment agent every once in a while, maybe every couple hours, maybe every couple days, depending on what your use case is. And you get metrics from that call, like almost like a heartbeat that tells you, "Oh, my agent is still alive in production, even if a real user is not calling it." And that's really good so that maybe your on-call engineers can know exactly when an agent is down and resolve the problem as fast as possible. So here's a couple of companies that are kind of really good for building with voice agents. Bland and Vappy are the ones that allow you to build drag and drop agent voice flows. DeepGram and Assembly AI, these guys allow you to have transcription. They release transcription APIs, speech to text, text to speech. A lot of developers for voice agents, they actually start off on Bland and Vappy because it's nice, it's drag and drop. But then as they want more customization, they end up migrating their tech stack to using APIs from DeepGram or Assembly. And if they go really hardcore, they even try to build their own kinds of models. So now let's talk about what we're building today with BlueJay. And I'm going to go and share my screen real quick to another tab. Right here. So we haven't launched the MVP yet. So this is all local, but I do want to show you what we're building. So once again, BlueJay is an evaluation platform that evaluates AI agents across modalities and industries. So we're pre-MVP, but I want to show you what's going on. So imagine you had a restaurant phone call. I've already logged a call with an agent that I built, and I've tried to order something. And I have like this audio file that kind of represents the entire call. I'm going to put it into the platform, and I'm going to try to go around and evaluate it. So let's go ahead and log our first evaluation. And over here, you can see a couple fields here that we're going to fill out together. So this evaluation is going to be for a restaurant voice agent. And let's say that this is, an agent responsible for placing orders, or sorry, not placing orders, taking orders, let's say reservations and more, right? And then for this knowledge base, I've gone ahead and found a menu that we can use as a sample knowledge base of the restaurant that this guy is going to, be emulating. So essentially, we have a bunch of spreads that you can order, and of course, we can integrate with vector databases. But for now, you can just throw in, your background as text. And then from here, maybe you want to have some custom questions that go beyond just things like words per minute that you want to figure out about your call, like success metrics almost. So let's do that. Let's add one question here that's were you able to answer every question that the user had correctly? And then let's add another one, maybe this one, right, where we're basically saying did the customer end up placing an order, and if so, when did this happen, right? From there, I'm going to choose this audio file, and I'm going to go find it real quick right here. And the goal here will be that once we log this eval, right, we're going to figure out whether we can get answers to these questions. Oh, okay. Answers to these questions that we had based upon a phone call. And of course, this is way faster than listening to the whole phone call right now, like what current voice agent devs are doing to get familiar with their data. So now that people have done this, they've uploaded this scenario, they can go and check out, oh, like there was no hallucination. Why? Oh, it's because the agent accurately described something. So no hallucination occurred according to the knowledge base that we popped in. And then with redundancy, it looks like we actually failed this check. So let's check why. And it looks like over here that the agent stated that we're sending a payment link to your phone now twice instead of once. So at some point during the call, and we'll see exactly where, that was actually said twice. And I remember when I was taking the call, that is what happened. And finally, let's check out, did the customer end up placing an order? It looks like a customer placed the order. And also, this is when the order was placed. This is how long it went on for. So this is interesting information to developers. And you have basically answers, whether a goal was achieved or not, for the custom questions that you tried to ask right here in a nice intuitive platform. The final thing that we're looking towards building, and that we're building out really with a not so amazing UI right now, is actually a custom pathway that represents what happened in your call. So let's go take a look at this. So over here, and of course, we can definitely make the UI a little bit better, but we have an idea of the general pathway and major events that happen throughout your entire call. So let's say you didn't want to, go through this, the audio yourself, but you did want to have a high level overview of what happened. This is a great way to see it. And you can have major things that happen. Like, for example, this is when the agent asked for spreads, here's when the redundancy happened, here's when the order got placed, and so on. So this is some really exciting stuff that we're trying to work on here to try to make the entire development process for voice agents and eventually all types of agents across modalities really, really intuitive. So anyways, that's how this product works. And now let's move back real quick. And let's just do a little bit of recap. So overall, we talked about agentic evaluation for voice and the idea that it is necessary because there's a lot of discrepancies between production environments and development environments. When you guys are building your agents, a lot of things can go wrong in production. In fact, more so than if you're building with with deterministic code, more so than if you're building with code that's not LLMs essentially, right? So you would want to use a strong evaluation framework, and that's what we're looking to build. We're going beyond just the static evaluation of words per minute or error rate or the standard stuff that you would get when you're evaluating a voice agent. We're also trying to do more qualitative analysis where we allow a voice agent developer to ask questions about their call and see if custom goals were achieved. And eventually, we want to have a nice built-out interface where we can track in a graphical interface what exactly happened in a call, similar to how Bland and Vappy do, but with your custom flow, so you don't have to develop just on their platform. That's what's going on. If you're curious, please scan this QR code and join our waitlist. We're planning to release an MVP later this month. If you guys are a voice agent developer or any kind of AI agent developer, we'd love to talk to you, because I think at this stage, our development's going really, really well. We just want to be able to talk to as many developer agents as possible, or as many agent developers as possible. So with that, thank you so much, Natan. I'll pass it back to you.
Thanks so much, Faraz. That's actually like really an interesting presentation. I think voice agents are gonna become like abundant today when it comes from like ordering things at restaurants to like calls for sales. And the main challenge is, how do you make these AI voice agents really accurate? So being able to evaluate not only the text, but also the audio kind of quality is very important. And I'm excited to see what you do here, because it's a really critical problem. So
thank you, Natan.
And Raj just moved to New York, and I'll hopefully see him tonight. And yeah,
I'm looking forward to speaking with everyone. I will be here tonight.
All right, cool. Well, thank you, Faraz. I'll definitely check it out, the QR code too. And thank you. Awesome. That was an amazing presentation by Faraz. Wow, AI voice agents and evals are going to be like huge, and I'm excited to see what he ends up doing, because it's a really important problem. And as he was describing it to me in person, it's like can be mission critical, and even for people that are trying to make more money at restaurants, right? So next up, we have my friend David Bernstein. Hey, David.
Hi, nice to be here.
It's great to see you. So David and I, for some context, have gone way back to when he was been building some of the concise concepts and spacey set fit libraries at Argilla, to now his work at Hugging Face. I'll let David take it away from here. He has an amazing presentation today about small agents, and yeah.
Cool. Thanks for the invite. I'm David. I work on ML and DevRel at Hugging Face, and today I'm going to talk about small agents, going from bells and whistles to agents and tools. So kind of getting rid of some of the fuzz around the concept. I will be talking about the small agents package, but not solely about the small agent package. So also about general concepts about for agents. Initially starting with what is an agent, going to like some general introduction to small agents library, and then moving over to agentic RAG, like an example use case of how to use the small agents library. So what are agents? There's no clear definition as of yet, but to kind of go through the buzzword bingo a little bit, we've got LLMs, like generative models that take an input and reproduce an output. Then tools or functions that these LLMs can call, and some logic or reasoning flow, like for example, chain of thought that helps the LLM to understand what kind of steps and tools it should use and take throughout the reasoning process. Then there's this cool blog post from Simon Willison, an engineer at Dataset, that actually prompted or polled the Twitter to get some definitions on AI agents, and he summarized them there. So I recommend checking that out. Recently, the Hugging Face ethics team, along with Margaret Mitchell, they actually published this paper on different types of agents, and they identified 5 agentic levels, going from simple processor that takes an input and returns an output, to routers where there's kind of an if-else statement scenario, to tool colors where the agent is able to kind of adapt and argue which tools to use and which arguments to use for those tools. Multi-step agent that has some kind of flow that it would go to, and can therefore itself decide when it should exit the flow and it has succeeded in the task. And lastly, an agentic system or multi-agent system, where there's multiple agents working together on different tasks, so to say. And these agentic levels, they actually come with increased autonomy for the agent, and therefore there's always a risk trade-off according to the paper. The paper identified 3 kinds of trade-offs: the inherent risks that are always present at each autonomy level, then the countervailing relationships that kind of trade off where increased autonomy might risk to increase opportunities as well, and an amplified risk where increasing autonomy magnifies existing vulnerabilities. And it outlines like several categories for those, like safety, security, true reliability, user interaction, task performance, and broader impacts. And when looking at these, what you can see is generally when you increase the autonomy of agents or agentic systems, you also increase the risk and not necessarily the returned opportunities. So it's always good to kind of keep this in mind when developing agents, because only for task performance, there's also like for assistiveness, efficiency, and relevance. And human likeness, you actually get something in return whenever you like add all of these tools and give the agents access to whatever you want. So normally it's always better to develop like these less autonomous systems wherever possible and be more concise and descriptive and more exact on how you're going to implement your agents. So the small agent library, it's small. It has only 1,000 or less than 1,000 lines of code, although that might have changed with recent PRs. It integrates with like a lot of models, modalities, and tools on the Hugging Face Hub, and the hub has more than 400,000 tools available on the hub. So all of these tools have been published as web apps on Hugging Face Spaces, and you can host and share and use the tools for free normally. So it's pretty cool ecosystem to build agents on. On top of that, Hugging Face, along with the small agents library, also released this free agents course that it's certified. So you can actually sign up, go through the course, and then get a certification from there. So that's pretty cool, and you can still join this cohort of more or less 70,000 people joining in. So let's dive a bit into the code for small agents. Creating a tool within small agents relies a bit on this pydantic workflow where you define attributes like a name, description, input, outputs, and these inputs, outputs, and all of the attributes, you normally try to make them as concise and descriptive as possible, because these are forwarded to the prompt for the agent throughout the agentic process. And it helps the agent generalize and reason as to how to use the different tools that it has access to. And afterward, you'll also have like a forward function with the normal processing logic for a tool call for the agent. And this is kind of similar to what you might see in other like Transformers frameworks. Then after having created this tool, you can actually share the tool on the hub. So you can push the tool in the hub where it will be converted to a web app automatically, like a Gradio web app. If you're not familiar with Gradio, maybe something like Streamlit rings a bell a bit better. And you can also load these tools back from the hub. So you'll have your tool, you can actually create a web app, you can share it with your stakeholders, and this automatically makes it way more accessible and approachable for like anyone that might find the term agents and tools a bit fuzzy. And you can actually see what's happening with the individual tools, with the individual agents as well. So that really helps with general understanding and oversight of the system. Then instead of using pure small agents library to create these tools, you will also use the Gradio library to create these tools, where Gradio is this web app framework, as I mentioned before, Streamlit, but then different. You can deploy these Gradio apps for free, which is nice. And in the middle of the screen, you can actually see an example of some code where we have like an image classification interface that takes an input function and takes an image as input and some labels as output. And on the right-hand side, you can see that interface in practice. So once again, you can share this with your stakeholders, and you can really see what's happening with your tools and what the input and output are. Then you can also share these tools to the hub as Gradio spaces, and you can actually import them from spaces as well. So you can look for a lot of spaces based on semantic search queries or functionalities that you might be searching for with your tools. There's several spaces that you can find and have access to directly. And one of these spaces might be, for example, the Flux Snell model that has been deployed on Hugging Face for free and can actually help your agents start generating images and these kind of things. On top of that, what you can also do is create this tool collection on the hub, for example, for labeling or for image generation or like diffusion tools, as you can see here. And then directly you can get all of these tools in one collection and directly start using them out of the box. So that's pretty cool too. So agentic RAG, I wanted to kind of go over how you might set that up for with small agents and keep it very simple and out of the box and straightforward. So LLM agentic RAGs are LLMs with RAG tools where they have the option to respond, improve the query, or reroute the query to like other APIs or external services. As you can see here, there's a user calling an agent. The agent would then potentially call this RAG pipeline that you've already set up, or choose to redirect to web search, some external API, maybe rewrite the query, and then generally limit the functionality to avoid it taking over the world. Within agentic RAG, you initially start with embedding all of your documents and contacts into a vector database. And this embedding step normally is quite costly and takes a lot of time to kind of work on like all of these embeddings. It requires GPU to actually do this at scale. You need to re-index your vector database. But there's this cool new package, Model 2Vec, and it works on static word embeddings like the Word2Vec that everyone knows and loves, but with higher accuracy than Word2Vec. And this allows it to generally vectorize 1 million documents in less than 10 minutes, for example, just on computer hardware. So this is great for prototyping, for like highly fluent systems, so to say, or for systems that require slightly less accuracy, because it's cheaper. You can run it locally, you can run it on whatever hardware you might want. Compared to the slightly larger sentence transforming models that are also a bit slower. Then there's also the trade-off that you might make between really experimenting with different chunking techniques and iterating and iterating and iterating, or using a longer context LLM that can capture like longer context in terms of retrieved documents. And on the right-hand side, you can see some code that actually embeds the text and creates an embedding column and then pushes that to the Hugging Face hub so that we have a data set with an embedding column there. Then we continue with indexing. For indexing, like the cost for a vector database within a RAG pipeline is normally somewhere between the 20 to 50% of the RAG spend, or of the model spend for RAG, which is quite expensive, I would say. So instead of directly starting with a vector database, what you can also do is move over to in-memory databases, like, for example, relying on DuckDB or Vicinity, because normally for k nearest neighbor with less than 100,000 records in your database, you can actually use like k nearest neighbor. After that, you might use approximate nearest neighbor algorithms where you can index the document, index the database while loading, or just store and load the index upon deployment. And on the right-hand side, you can see, for example, where we import DuckDB, we write a DuckDB query that does cosine similarity search on a external Hugging Face dataset. So this is the dataset that we created before. We can just query the dataset with DuckDB and then directly get the most similar results from there. So nothing fancy here, no heavy vector databases, just relying on DuckDB, Hugging Face Hub, and continuing with our RAG stack. When retrieving, we actually want to kind of capture all of this logic in a Gradio web app, for example. You can deploy these for free, use them locally, install them with requirements.txt, or even as a progressive web app. And this is once again like some code to see what this would look like, where we define on the right-hand side a text box as input, a slider to select the number of retrieved documents, the button to search, and we would then forward this to the agent later on, where the agent has these like arguments and parameters for like the tool calling to its disposal. And we would then deploy it, and you kind of get the UI as we see on the bottom right side. So creating the agents, we deployed this cool retrieval tool to the Hugging Face app. So we can import this tool from the hub. We can kind of define a name and a description to let the agent know what we are dealing with. And then after, you can pass that tool to the code agent and start running queries. So it's quite easy, like embedding is easy, the in-memory vector search is easy, and you don't need anything fancy. So agents are licensed to call, add the tools that you actually need, be precise and concise with the names and descriptions, make deterministic tools, because it's more reliable, and agents are already stochastic, so better to rely on deterministic tools in the meantime. Combine tools as much as possible. So for example, your agentic, like your RAG stack, you can combine those in one tool instead of passing all of these tools and letting the LLMs find out each of these individual steps, and potentially adding some logging and printing that will be actually picked up by the agent. So as the presentation, if there's like questions, contacts, feedback, feel free to use one of these QR codes.
Wow, that was remarkable. Thanks so much for the presentation, David. Small Agents is honestly like one of my favorite libraries today, and this whole like agentic RAG thing has kind of got me thinking a lot, because I've been thinking a lot about how to improve RAG, and it's kind of crazy to see like the evolution life cycle from where things kind of first started to like where they are now, and I'm really excited to see what's to come for you and the team at Argilla and Hugging Face.
Cool. Thanks for having me over. Good luck with the rest of the day.
Thank you so much. Amazing. Wow. What an incredible talk from David. Wow. He's been one of like the leading contributors to the open source AI, and just wanted to give him a shout out. Next up, we have my good friend, Rehan. So Rehan is actually the authors of one of my favorite newsletters out there when it comes to AI, Digestible AI. He actually is a AI consultant at Accenture, where he helps Fortune 500 clients build AI and ML solutions. He's going to talk a little bit about agentic AI and newsletters, as well as maybe put a plug for his Digestible product. And I'm really excited to kind of hear this talk.
Yeah, absolutely. Sorry, guys. What's up? How's it going? I'm Rehan. Natan, thanks so much again for the opportunity. I think this is going to be a great talk, really, really valuable for people that are into content creation and potentially creating newsletters as well. And a quick point about what David talked about too. I've been playing around with small agents myself. I did a piece on small agents with vision language models, and it's been working pretty well. So I highly recommend small agents also. Awesome. So let me go ahead and start sharing my screen, Natan, and we can go from there. Let me know if we can see this. Cool. All right, guys. So as Natan mentioned, I currently work at Accenture, where I lead a lot of our AI projects out of the Northeast. And I also work on a newsletter, Digestible AI, that really helps to make AI accessible to all audiences, whether you're an engineer, a knowledge worker, or just even an AI enthusiast. And my whole mission around this was to, like, how do we make AI something that isn't guarded by just engineers, right? We want it to be fruitful for everyone as we move into the next few years. So my talk today is going to be about an agent tool that I had worked on to build out some content for my newsletter. And this is, for full transparency, a side project that isn't being actively developed today. But I started with the broad question about, okay, how could I have a team of agents curate content for the newsletter and then write me a first draft? So with that question, I ended up devising a little plan using Crew AI and tools from Exa to go ahead and do exactly that for me. And in the little demo I'm going to show today, we have here a researcher agent, a newsletter agent, and a designer agent. So for example, the researcher agent has access to the web, so it can go and grab all of the tools, all the articles based on parameters that I specify. We have a newsletter editor, which emulates my writing style, or at least attempts to do that. And then we have a designer and compiler, which goes ahead and creates the HTML doc that I need to output that. So really quick, let me go ahead and show off the actual tool. And this is a pretty simple implementation, in my opinion. It was done with Crew AI, a very simple fast API app, and a very simple like React front end here. So the front end here that I wanted to use, and the vision that I had for this was, okay, if I had some links, some parameters that I could start giving to my agents, how can they take that, make content out of it? But then also, if I don't give it any links, how can they go and reason and find the right links that I want to talk about for my audience? So here, I've given it 2 links here, a couple of recent things from CNBC and Reuters. So this one is Intel shares rise after Vance promises to safeguard American AI chips. And then this is about how Grok secured 1.5 billion from Saudi Arabia. And I put those links into here. And essentially this is in the back end or in the front end, how this is working. I'm not going to show off the result quite yet because I want to talk through a little bit of the implementation and the methodology behind how we built this. So I want to show off crew.py, API.py, and then the agent configurations that I have. So really quickly in crew, we have basically where you define all of your agents. So in here, I've used the Crew AI framework again, and I have, like I mentioned, 3 different agents, right? One that's a researcher, one that's an editor, and then one that is a designer. And given these agents, I've given it the appropriate tools from Exa that it needs to go and achieve the tasks that I want it to. So for example, I have a tool called searching contents and then get contents. So searching contents essentially gives you, like, it lets the agent go search the web with the Exa API, and then get contents actually goes and scrapes the information from the articles that I'm talking about. And then with the after we define the agents, we have tasks. So I have a research task, an edit task, and also just the newsletter task. Switching over to just the API implementation of this, what I have here is basically I just call in the newsletter generation crew that I've defined elsewhere, and I'm passing it the links, and then I'm running it through the API. And then so once you go ahead and you put in your links into the front end, this is how the result is returned. And then very quickly, the agent configurations. Here I have the researcher, the editor, and the designer, and they're all given roles, a goal, and a backstory. That's how Crew AI works. You're given these 3 parameters, and that's how it's able to kind of reason what it wants to start doing. And then finally, some tasks that I've defined here. The research task with a pretty thorough description of how I want it to act. Again, this is all iteratively done with via prompting. I've given it an expected output, and then also the edit task. And then finally, there's an expected output for that too. So switching back over to the actual output of this, I did a pre-generation of this because this does take a little bit of time to run, and I'll show you exactly the outputs as well. So here is the newsletter template that it's spun out for me, or the first draft of my newsletter. And it's given a weekly AI news roundup with a couple of feature sections, and it's able to capture the links that I had given it. So there was, again, the piece about Intel, and then the piece about Grok, which it was able to give a summary, and then 3 supporting points. And then for things that I was not able to put in the link for, it went ahead and searched the web for what it thought it was relevant. So this one, Innovation Showcase, something about Google DeepMind's Gemini 2.0 model updates, which came out last week, which is pretty relevant for my audience, which is awesome. This article, I think, came out today. I was checking on it, and it says Baidu to release a next generation AI model this year, and it's from February 12th. So really good job on the part of the agent to find something that was pretty relevant. The thing is, I don't know if it's like how to use, I don't know if this is accurate, but at least it was able to find this. And then a couple other points, we have industry intel, and then the other sections of my newsletter that I like to start curating, and then just more points given by the agent, which is pretty cool. And finally, I just want to show off a little bit of how the agent was able to reason in the output. So I've actually just captured the output here from the Fast API app. And just to walk through what it's actually doing, it literally has grabbed the prompts that I've given in the agent configuration, the task configuration, and then it's gone ahead and thought about, okay, this is what's relevant for digestible AI. This is the articles that I found. This is the contents of it. This is how I'm able to synthesize, summarize it, and edit it. And then also in the backend, which I forgot to mention, I have an HTML template that I want this to spit out in. So it's actually went ahead, understood the HTML template, and then grabbed whatever it has found from the web, synthesized, and put that into the HTML template as well, which is pretty awesome. And that's how I was able to get the ultimate generation. That's how this spits out. So yeah, that's basically all I wanted to show here. Really cool example of how you can streamline content creation, how you can start researching things, because people who create content, they know that it takes a long time to do it. And Crew AI implementation was a great first step for this. And again, this is not really something that's being actively developed by me, but from an iteration standpoint, things I would like to think about is like making this faster, definitely playing out with some open source models too, and potentially going low code for this too, and seeing how that works. So yeah, and here's just a couple of QR codes if you guys want to check out Digestible AI, and then also my LinkedIn. Feel free to. You're more than welcome to. Cool. That's all I got, Natan. Thanks so much.
Really interesting. I guess I have a few questions for you, Rehan.
Yeah.
So for one, I remember when we were talking at the last like Anote Mindstone AI meetup, and you were mentioning like, yeah, if you were to kind of think about building this again, one thing you might look into is like different low-code agent frameworks like Nano AI, right?
Yep.
It's kind of curious your perspective on like low-code agents versus like coding kind of SDK agents like Crew AI, and your thoughts there.
Yeah. So Crew AI, like doing this way was definitely very good for my learning because I hadn't really built agents before using Crew AI. So from a standpoint of like getting into the code, learning how to configure agents, I think it was very good for learning. But from a more practical perspective, when it comes to building a POC, I mean, for myself, I would probably start with some of these low code things. And if I wanted additional customizability or scalability, then I can translate that to code and whatever that looks like. So my 2 cents is starting there, proving the value, and then going to a broader implementation there.
Yeah, that makes sense. I guess another question. So obviously you've been creating really awesome like content with Digestible AI. I know you were kind of sharing a lot of that in the Anote Slack channel, the early days. And I guess I'm kind of curious, with this newsletter AI agent presentation, what do you think kind of like the future of AI related content might look like? And, do you think there's a place for that? Or do you think like really the best kind of content will always kind of come from people,
No, I think it speaks to kind of how fast we're moving in the space, right? Like we're seeing more capable models come out every day, and the fact that we're able to go and emulate some people's writing styles pretty easily says a lot, right? So writing, I think, in the age of AI, like is going to be AI dominated, but there will be some level of effort you have to put in to have the voice, right? Because if you write, you want to tell the story, you have to tell it from your perspective. Similarly, I'm seeing something with like video, right? So video, Instagram Reels, things like that are being AI generated now. I think that's going to be something that is to look out for in the next couple, like 6 months to 12 months too. So I think the future will be AI driven content. It's just a matter of how well you can kind of connect with the audience that you want to build.
Yeah, for sure. Also, I just wanted to kind of personally put in a plug for Digestible AI. So, some of the content that Rehan and his team have kind of been putting out, it like helps me personally stay informed about the different things happening in AI. Like, I feel like almost everyone can kind of relate to like, wow, every single week there's a new advancement, and I don't want to fall behind. So, for me personally, just going through Digestible AI lets me kind of stay up to date with what's happening, and I think his newsletter is awesome, and I'm excited to hopefully like work together to expand it across America. So
yeah, thanks a ton. Appreciate it.
Awesome. Well, thanks so much, Rehan. I'm gonna, yeah. So, Chi, you're here. I'm gonna let Chi in.
Hi, nice to meet you.
Hey, it's nice to see you too. Chi, I actually first kind of reached out to Chi when I was building multi-agent AI frameworks, and she was like a really large contributor to AutoGen, right?
Yeah, I'm the founder of it.
Yeah, so AutoGen is obviously one of the most amazing multi-agent AI frameworks. Our team has kind of actually used AutoGen a lot, and we have like a lot of inspiration from like the stuff your team has kind of put out. So just wanted to like personally thank you for building that.
Thank you, appreciate that.
I guess Chi, is now AutoGen is now AG2, and has been a senior staff research scientist at Google DeepMind. He has a PhD in computer science from the University of Illinois Urbana-Champaign, and has extensive experience leading tech at companies like Microsoft and Facebook. And in addition, he's done a lot of really incredible work with open source AI with AutoGen. I personally think this is going to be one of the most powerful and transformative kind of technologies in years to come, but I'm biased, obviously. So I'll kind of Chi tell you himself.
Thank you. Let me share my slides. Great. Yeah, thanks Nathan again for inviting me to the summit. I'm really excited to talk about the recent update about AutoGen and actually the new repo called AG2 with the vision of building the open source agent OS that enable developers to build any agentic systems easily. We already have a very large community on Discord. Let me start from the motivation. About 2 years ago, when I was thinking about with this powerful generative AI technology, not only they can generate high quality content like text and images, but also in future they're not limited to these simpler tasks. They must be changing the industry fundamentally by accomplishing much more. But how would that future of AI application look like? After months of hard thinking, I made a bet, very early bet about agentic AI. At that time, most people still don't think it's a viable kind of notion. But I'm surprised to find that how quickly people are adopting that concept, and now it's this agent becomes a really big thing. The reason we made early bet is we think that this is the best way to maximize the utility of the generative technology and make them execute increasingly complex tasks on behalf of human. So you can finish really hard, difficult tasks from end to end. They naturally have useful interface because human can use natural language to interact with them. And they can also have much stronger capability going beyond what a single model inference can achieve, and have multiple steps and use tools and connect with humans and so on to achieve much more. But the third reason I think it's not commonly talked about, and that is if we think about agents as a really valuable concept, and think about using that as a basic unit to build future software, then they can become a transformative software architecture to fundamentally change how we build future software. So and that is like one more step we thought ahead about. Not only we can build agents, but we can build lots of such agents and make them interact with each other, and build a stronger, bigger system. And so that's the kind of vision we had. And over the past years, we have been pushing that initially with this AutoGen development. Initially, AutoGen was developed inside another open source project called Flammo. That's a AutoML project, open source project I created also like 6 years ago. And AutoGen was initially a sub-package inside Flammo. And in August last year, 2023, 2 years ago, we wrote a kind of a simple technical report, and then in October we moved to a standalone repo on GitHub and became a top trending repo on GitHub, and then attract a lot of interest and received many rewards along the way. What made me more excited is to see how many kind of diverse applications we have enabled along the way from both enterprise customers and startup companies, and also science explorations. And we summarize that learning in a course deeplearning.ai called AI Agent Design Patterns with AutoGen. Recently, we made a further development called AG2 based on AutoGen, and we made this open governance repo called AG2 to accomplish our open source agent OS vision. But it's backward compatible, so all the existing packages of AutoGen is still maintained by the AG2 repo, and all the existing functionalities can still work. And although there have been a lot of developments with more rich features in the AG2, but the fundamental concept and the program abstraction has not changed since the beginning. We have been developing new features all the way without breaking anything fundamentally. So the key concept is very simple. So we want the developers to develop any complex agentic systems with simply 2 steps. The first step is define the agents, which are conversible and customizable. Here, the agent abstraction is very generic. It can use generative AI models as backend, and can also use tools or human inputs as a backend, or you can use a mix of them. And these are some primitive agents you can create in the beginning. And how do you create stronger agentic system or stronger agents? The answer is to get them to talk. So we propose this conversation programming approach. You can use a simple like 2-agent conversation or multiple or more than 2 agents in some other more complex conversation patterns, including sequential chats, nested chats, group chat, and more recently Swarm patterns. These are very flexible, and you can also define your own orchestration patterns very easily. And nested chat, for example, is a way to combine multiple agents and put the inner conversation inside a single agent, and let that single agent to extend its capability in an unbounded way. And after you have one strong agent, you can further combine with other strong agents and to create even stronger agents. So that's a recursive way you can expand the functionality of the system. And here's, if you go to the ag2.ai website, you can find a YouTube channel that talks about some of the most interesting new features. And I use this slide to summarize these new features in the 3 categories. On the interface side, we are building, we're trying to make it easier for for both users and developers to develop agents and use agents. The Captain agent is, for example, is agent that is able to take the user's request about a complex task and try to break it down and create other agents on the fly, and to make it simpler to design a multi-agent system. Basically, we want to use the agent to develop the multi-agent system instead of the developers to manually kind of do all the experimentation. And real-time agent is enables very strong capability of using real-time communication, but together with multiple other agents doing the hard work. And there are many other examples like graph rag in the strong to make the capability stronger, and use reasoning agent to enable you to use any model, not just the thinking models, to perform similar reasonings, similar to the O1 thinking or Gemini thinking models. And in terms of architecture, we are also providing more and more of programming convenience. For example, tool-based handoffs, shared content variables, and structured output. A lot of these are also inspired by other developments in the agent AI space. Here's a simple demo about some combination of the new features, what we can do with them.
Hi all! Let's jump into a live demo of one of the key features of AG2 0.6 release, Real-Time Agent.
Welcome to Agentic Airways. Please wait while we connect your call to the AI voice assistant. Okay, you can start talking.
Can you please provide more details about your request?
I would like to cancel my flight.
Your request to cancel the booking has been noted. I can assist you with canceling your booking. Could you please confirm which flight you are asking to cancel?
Flight 123.
You've confirmed that you'd like to cancel flight 123. Just to confirm, you're asking to cancel flight 123. Is that correct?
Yes.
You've confirmed that you want to cancel flight 123. I'll go ahead and process that cancellation for you. Thank you for confirming. Would you like a refund for your ticket, or would you prefer to receive flight credits?
Flight credits.
You've chosen to receive flight credits. I'll proceed with processing that for you. Your flight credits have been successfully processed and will be available in the next 15 minutes. If you have no further questions, I will consider this case resolved. Thank you for reaching out and have a great day.
Thank you. Goodbye.
So what you have seen here is one real-time agent talking with the user, but there are multiple other agents as you see from the screen that does different work but send that messages to other agents so that they can coordinate. And here's a simple system architecture, roughly showing you how it's working. In the previous demo, we used OpenAI API to generate the voice, but you can easily change it to other models like Gemini, and you can also configure different models for different agents. And this demo that combines both a real-time agent plus swarms plus some other orchestration functionality we use, and you can easily plug in other functionalities into the system. In the rest of the talk, I want to briefly explain why choosing AG2 as an open source framework to build your agents and extend your kind of agentic capabilities. So the first one is about having this agent native design since the beginning and very early. We have been using a forward-looking way to design the system so that it can accommodate all the future technology involvement. And in the past 2 years, this has been proved again and again. As every time a new technology is developed, we can easily enrich the functionality of the system without breaking the fundamental abstraction, so that we are able to support many diverse and highly sophisticated use cases. People have been also using AG2 to tackle some very hard benchmarks, including software engineering, web, and others. We have been still pushing the frontiers with advanced research. And so let me briefly mention the diverse use cases. Since the beginning, we have received many kind of enterprise customer interest from all the different verticals, and over the time, we have been seeing all the different use cases and contributors from organizations from all over the world. Here's just a very small sample of the production use cases we have seen. They span across many different areas, as you can see, from trading, from chip design, customer support, cybersecurity, data engineering, and to marketing campaign generating, including the newsletter generation. I remember there was a journalist who reached out to say they were able to use AG2 to accelerate their report writing sometime last year. And there's healthcare use cases, software testing, and so on. I can give you one example, the chip design use case from NVIDIA is really interesting. Chip design is a very time-consuming task for them, and they were able to use AG2 to build solutions that help with human designers to reduce the time for some very hard tasks from days or weeks to just several minutes. And they have still exploring more with it. So that's a huge value, and this is a similar story we have seen for many other use cases as well. And chip design is just one particular example, highly sophisticated engineering domains, and there are a lot of other scientific use cases also for example, from MIT, who have built solutions for protein designs, material design, alloy design, and most recently, Psi agent that can do general purpose scientific hypothesis generation by using ontology knowledge graph and simulate a team of human scientists to back and forth do planning, reasoning, using knowledge graph to connect seemingly unrelated domains, and eventually generate a very comprehensive report about why this is a good hypothesis. And they can often generate surprising kind of results that better than a human scientist can do. And that's the kind of very interesting and very attractive way to accelerate the future of scientific discovery. We have also seen people topping hard benchmarks. Here's one example from the Sweet Bench Lite. That is one very hard kind of software engineering task requiring people to solve real GitHub issues to fix real software bugs. And the top ranked solution used AG2 to build a very cheap solution, but achieved top ranked performance. And they can fix almost half of the task in the Switch Bench Lite with no more than $1 cost and average just a few minutes per fix. You can find the community talk from our YouTube channel about how they achieve that. And finally, I want to mention that we have been making cutting edge research, especially different ways to optimize agentic systems. There are multiple techniques which optimize different metrics and choices. Eventually, we want to combine the different techniques and offer a single solution. I think the Captain Agent is one good example of how we could achieve that. As you can see from the picture, the Captain Agent takes a hard task from the user. It can use the existing library of agents and tool library to generate plans and build a team, either with existing agents or generate new agents if needed. And then have multiple agents working together to solve a problem and keep reflecting on that and keep revising the plan until the problem is solved. So this reduces the effort from the developers to manually optimize the agents and makes the whole process automatic. And the newly created agents can be also added to the agent libraries, so it can also improve over time with self-improvement.
Hi all.
That's all I want to talk about in this short talk. We have a lot of other useful and resources you can find from the website, and also you can find a lot of other agent builders on our Discovery community. And we welcome everyone to join and build the future of agents together. Thank you very much.
Wow, what a remarkable talk. What's crazy is I feel like, what was a theoretical concept in like a few years ago, where you'd have these teams of agents working together in a generalist framework, similar to the way people do, kind of today is like something that you guys have built and have helped like a lot of enterprises with, and just has like limitless potential, right? And it's kind of been used today to like beat a lot of the existing benchmarks like Sweetbench. And we personally at our team kind of have like leveraged a lot of your code. So we're just very thankful for your contributions to the field. And yeah.
Thank you, Nathan. Yeah, I'm happy to learn more about your use case in particular, and see how we can help further. Yeah, thank you.
Amazing. So that was Chi, the founder of AutoGen, AG2 now, which essentially, for those who don't know, kind of created the Magentic One, a multi-agent AI framework, which is one of the most popular agentic AI frameworks out there. And it can be used, I think, in my opinion, it's going to be like one of the most transformative technologies in years to come. And we're really grateful for his kind of contributions to like the open source ecosystem as well. Next up, we have some really incredible speakers. They'll also kind of share some details of a pilot we've been doing at Anote. We got TJ, Deepa, and Manish. Thank you guys first for being here today. I'll let you guys do the introductions and take it away.
Thank you so much, Natan. I'm TJ. I'm the founder of Auto ABM. I'm working with Deepa and Manish, who are my technical co-founders. Auto ABM is an end-to-end ABM solution that uses AI agents to orchestrate all your ABM processes. So yes, this is Auto ABM. And the problem with ABM right now is that it's inefficient and fragmented. So most teams are juggling multiple tools. doing a lot of these tasks manually, and working with partial data that's fragmented across multiple sources. And they're also missing buyer signals because your standard ABM platforms are relying only on structured data, and that's not very timely. So you're overlooking valuable social media posts, email, or forum discussions that might be happening right now. There's also problems with compliance and brand voice. So there are some inconsistencies when multiple marketers are working on the same campaign in terms of brand voice. And you also risk legal breaches without your automated checks for data privacy and brand guidelines. So the solution for this is an end-to-end ADI-driven ABM platform. So we're unifying the account targeting, the personalized outreach, the compliance enforcement, and the analytics all in one platform. And we're also leveraging the unstructured data. So we're looking at NLP-based sentiment and topic modeling through social chatter, and we're turning that into actionable insights that the agents can use. We're also using a multi-agent workflow. So each one of the agents is specialized to its role. There's a CMO agent, ABM manager, and the content personalizer, and they all collaborate to automate the process from start to finish, starting with strategy and ending with execution and results. So we integrate AI and NLP as part of our product. This enables us to have real-time sentiment data, as well as research different topics and perform compliance checks through our external APIs. We also have the multi-channel execution. So this means that the orchestration can happen across LinkedIn, email, all your paid ad channels, and also combines all these analytics in one place for you to track your ROI. And we also have the automated enforcement of your brand voice, making sure that you're compliant with your standard data privacy regulations, and making sure your tone stays consistent across all your assets. So here's a little overview of the agents in the process. The first one is a CMO agent. So this is like your high-level strategist. And they're going to use the web scraping tools to perform market research, figure out a plan to differentiate from your competitors, and ultimately generate themes for your marketing campaigns. And then the ABM manager is going to take those themes and create a list of accounts and contacts, enrich that list with a whole bunch of third-party and the real-time NLP data from the social media sentiments. And then the content manager is going to take both of those outputs and create a personalized content campaign formatted for each of those channels that we distribute. Finally, the execution team is going to take all that information and using existing marketing tools and integrations, the campaign will be automatically executed across all those channels. And finally, the marketing analyst will come in, monitor the campaign performance in real time, generate a report, and also offer like an in-depth analysis and recommendations. And the great part about this is that we all know that AI has its limitations today, so we want to keep a human in the loop. And at each stage of the process, the human can suggest ideas, make edits, review and approve all of the themes, campaigns, lists, and assets generated by the agents. And at the conclusion of each campaign, the AI is going to suggest tests and improvements for the next iteration. And the ultimate goal of the platform is to have it learn from its previous iterations and optimize itself over time to reach the campaign goals. It's also going to memorize the patterns of what's successful at both an industry level and a company level. So it's going to take not only the data from your company, but also data from your competitors in your industry and figure out what's working right now in terms of your strategy. So I'll pass it over to Deepa and Manish now. We're going to talk a little bit about the technical architecture.
Thank you, TJ. Hi, my name is Manish. So in the technical architecture, we have the agentic framework as Crew AI. So it's a very famous framework, and we're kind of using that. And all the agents are talking in sequential manner, meaning the CMO agent talks first and does all the research, then later it kind of supplies all the information as a context to the next agent. And we are also doing some planning and in memory while having the agents conversation with each other. So on a whole, the agentic framework is based on Crew AI. Then the next is human in loop. So we have a continuous iterative feedback after each agent's conversation. And as a front end, we are using Panel UI, which is a sophisticated WebSocket a provider for our Crew AI. And as an API integration, we are kind of using two APIs right now. That is OpenAI and Serper. OpenAI is for large language model, and Serper is actually API driven search-based content, which we are using to leverage to find out the competitors' research and to research about the company and whatnot. Next slide, please. Yes. So on a high level, we have almost like five agents on the platform. On a higher level, we have a planning agent, which kind of does all the planning for all the five agents on the bottom. So once the planning is done, the company researcher, what it does is that it'll take the company name that you want to research about, and once the company name is supplied, all the content that is related to that particular company in the entire search base is extracted, and those data is being condensed, and the large language model will try to give you a very good overview about the company, like what are the services provided, what is the product, what is the mission, vision, etc. And later, all the information is supplied or provided as a context to the competitor researcher. Now competitor researcher is another agent which will try to identify the competitors based on the company's product vision and mission. So we will jot down all the competitors, their weakness, their strengths, and whatnot. And this context is then supplied again to the social media researcher. Now social media researcher, we nowadays know that in Reddit and Quora and in Facebook, people talk a lot. So they talk a lot about the companies, they talk a lot about what they provide and what they don't provide. So we kind of extract the sentiments from those social media platforms, and we try to have a context for us to provide some social media themes. So all this content is supplied again to the CMO strategist, the third one, sorry, the fourth one. And the CMO strategist will develop a high level proposal which includes marketing themes for the last agent to tackle on. And the last agent is content generator. So content generator has the context of all the research that has been done until now, and it will kind of generate blog posts, email, and different variations of content that is required for that particular company. Next slide, please. Yeah, handing over to Deepa now.
Thank you, TJ, and thank you, Manish. Okay, we have already discussed what is our problem statement, what is our solution. Let's talk a little bit in deep about the workflow. I'll keep it really short because we have developed a small MVP which we will be showcasing after that. And since we are running that particular thing right now on our local, so it does take a little bit time, so any kind of fill-ins or any kind of questions we can definitely take, and we can provide more details at that point. Right now the CMO agent that you are able to see is kind of like a boss above company researcher, a competitor researcher, social media researcher, as well as the marketing theme analyst. We have to keep one thing in mind, that all these LLMs have been given their own persona. So for example, if we talk about the company researcher, right now we have a persona that our company researcher has been working in the similar field for almost 10 years, so he does have this particular skill set. They also all like him, all the other agents that we have, they have their own persona, that they have been working in this particular company for this and this year, so this is their skill set, this is the experience, or this is the project they have had. They also have certain tools in their belt. Not all of them are doing the same things. For example, our company researcher has Serper right now, and we were also looking into Apollo APIs and everything. So these kind of tools they can have, so their tasks are accomplished better. Not all the agents need same things. Again, the LLMs also we can definitely keep different, because certain LLMs do not need a lot of content generation, but certain do. So according to the needs, we can definitely do. Right now, the company researcher, as Manish mentioned, it is going to basically whatever company you're giving, let's suppose Nike or Adidas, it is going to go to their website, go to different platforms where their information is available, and trying to find out information, when it was established, what it is doing, what are their products, like that. It is going to pass that entire information, which we are also saving in an MD file, so that we can have a look at later also, and that will get passed on to the competitor. And then social media is going to do the research, then we are going to have 3 4 and themes in the marketing, then everything is going to go to CMO manager. He's going to define which is good, which is bad, and then we can choose which theme we want to go ahead, and we'll have the content. So without further ado, we'll just move to the demo. Over to you, TJ.
Thank you so much. So here we have the Auto ABM in its MVP form. So we're going to generate a strategy for Salesforce. We input our data right here. It initiates research. Currently working on the UI to get a little feedback loop here in terms of progress. But right now it's going to run in the background. We originally intended to do some Q&A, but we're pretty short on time here. So I'm just going to do kind of a pseudo Q&A. And one question that I really get a lot is, what's the difference between using this kind of system and the existing tools that are out there, like just putting this query into ChatGPT? So could you share a little bit more about that, Deepa, as this runs?
Absolutely. So right now it is taking a little bit time because it is on our local and everything. We are definitely working on the UI. I think the major difference right now, for example, you can definitely go ahead and give this question to ChatGPT, not a problem. But what are they going to do is ChatGPT is going to go simply and do an over analysis and then give you the information. Right now, for example, our first agent who is going to just look into the Salesforce is going to dig more into it, going to get more information. Like we can definitely see over here, it is going to tell us what is the information, when it was founded, who are the founders, what is its mission, what is the vision, what is the proposition. It will also tell what kind of audience they are normally targeting, what kind of community they have, the pricing. And definitely if you need more additional detail, you can definitely tell in here that I need more. But if you think that it is fine enough, let's go ahead, let's look at the competitor, we say looks good, and then it is going to again take a little bit more time to find out the competitors that are present in the market. Normally it gives us around 10 to 12 competitors that are directly in competition. Sometimes we might have to refine further. Manish, do you want to add something more for our competitor researcher?
Sure, sure. So in the background, what's happening is that think of it like a layman research. The way they do is that they go to Google search, they try to find out who are the competitors for so and so company, and you get like top 10 or 15 links. And what do? We generally go into that links and we read about all the content. We kind of categorize, these are the details that are really important for the particular company, and these are the details are not important. That is the same thing that the agent is doing right now. So the Serper API tries to give you all the links, and within all the links, the data that is being embedded, that is given back to the LLM, and the LLM stores that as a context, and it'll try to go to within all the like 10 to 15 links that it provides, and based on that, it'll try to consolidate all the information based on the competitors or based on the report or based on themes and everything. So that is how it will try to jot down all the details. It'll create an MD file, the markdown file, and that's how it'll try to provide back to you on the screen. So once you have that on the screen, either if you have an extra detail that you would like to include in the report, then you can add that as well. Else, if you think that what, everything is better, you can go ahead with that, then you can give a thumbs up, like looks good, and go ahead. So that is what is happening in the background. And right now it is hosted on our system, like the server is our laptop right now. And that's the reason why it's just kind of giving little bit of time lag here. But we also have in our pipeline that to host it in a cloud based service so that it will be much faster.
Yeah, are there any questions from the audience right now?
Hey guys, this is an amazing presentation. I personally really enjoyed it. I know we're like a little bit over time, but just wanted to kind of give you guys a chance to add anything else you wanted to share, because I thought this is like a fabulous talk.
Yeah, well, we're currently just kind of waiting for it to spit out the rest of the information. But in the interest of time, I'm going to be attending the in-person event tonight. So you can definitely, I'll bring my laptop. We can go in and dive into the other outputs that it'll, generate eventually. But yeah, next step after this is basically it generates both the competitor research, then it dives into the social media analysis. So all of that is currently working. It just takes a little bit of time. So if you're interested in checking that out, come see me at the event.
Yeah,
Thank you so much.
We'll set up a startup demo table for TJ and his team, and I highly recommend checking this out. And job well done, guys. Really appreciate y'all.
Thanks so much.
Thank you so much.
Yeah. Thank you. Wow, that's an incredible talk. TJ, Deepa, and Manish, should be incredibly proud of the work they've been doing. it's a real example of a working functional multi-agent AI system. And like, wow, should be very impressed. Say, next up we have someone who's actually been an intern on the Anote team this summer, a student from Cornell University, lives in Chicago, but now is in Ithaca, who actually helped build one of our exciting agentic AI projects, Sanya Mahajan.
Thank you, Natan. Yeah, I'm super excited to be here at the summit today, just being able to talk on one of the projects that I was able to work on this summer. So yeah, I'm a sophomore at Cornell majoring in computer science, and I had the opportunity to intern at Anote this past summer and really work kind of on AI-assisted RFPs or requests for proposals. And that's a lot of what I'm going to be talking about today, about how we kind of streamline the grant writing process, specifically in RFPs, and lead you through how we were able to do that, and also show you some of the documents or grants that we were able to produce using AI. So I'll go ahead and share my screen. Let me just pull this up.
Yeah, and I guess for some added context, so we essentially oftentimes use this AI RFPs just to kind of do some like the initial research on like some ideas of where we could kind of best apply the grants. And it's very helpful just for like the brainstorming session, and can save a lot of time. So
yeah, so just like with that, in general, filling out applications is a very standard process that we see, whether that be through job applications, customer proposals, pitches, but it can be very tedious and time consuming, especially if we are kind of juggling other tasks, especially in the workplace, trying to fill out applications while having to manage your own responsibilities at the same time is a lot to juggle. And specifically in the RFP or request for proposal space, a lot of the startups want this non-dilutive funding, but they don't have the time and they don't have the resource to apply to all of these by hand. Writing these grants are very tedious. And the reason that they are is because of that customization effort. A lot of these proposals need to be customized to a very specific prompt, and a lot of efforts needed in order to kind of provide unique business context and niche problems. So just highlighting different experiences from a business and different problems within each grant application is a lot to customize. And the fact that it has to be done by a human right now is a really big issue, because a lot of that time can be dedicated to other responsibilities rather than just like filling out pages and pages of grant applications. But as we can see, a lot of like how startups gain funding is also through grants. So it's super important that they're filling these applications out in the first place to obtain that funding. A little more into the statistics of that. In each grant, there's around 10 to 50 pages per grant to fill, more than 100 hours spent on them. And in each grant, there's a 10 to 20% success rate, which is just due to the fact that there is a lot of competition, a large number of applicants seeking funding for a lot of diverse projects. And at the same time, there's a lot of grants from federal government and globally that are available to various sectors. So this is kind of like the issue that we were trying to look at when developing a prototype or a product to solve that. Each grant has specific guidelines and objectives, and as we see here, 40% of the time that goes into submitting a grant comes from actually writing it itself, which is a really tedious process. And along with that, 30% of it is research, whether that be about the company or the organization that's sponsoring the grant or something else on that line. So the three ways that we thought that AI could streamline this RFP process were through customization, document compilation, and compliance checks. So AI is going to use past data. For us, we use a pre-trained AI model, and just using the past data and information about Anote to draft tailored responses was kind of how we were able to customize each grant depending on what we were applying to. They also auto-generate structured documents and ensure all grant requirements are met, which is kind of like a little harder to do as a human, as you have to scan pages and pages and make sure that when you're writing it, you're sticking to the relevance and you're sticking to the grant requirements. But with AI, they'd be able to generate the grant for you, and all you'd have to do is give it the final check and revise or tweak anything that you want, so that they're taking most of the responsibility of it. specifically how we streamline the process, I'm just going to walk you through it, and then I'm also going to go over the technology specifically later on. But we started off by kind of loading and pre-processing all this grant data from 3 main websites, including nih.gov, sam.gov, and grants.gov. And then we used TF-IDF, return frequency, inverse document frequency, and cosine similarity, which I'll go over later, to kind of find the n most relevant grants given keywords. So for us, we were giving our model keywords such as Anote, data labeling, AI, document labeling, and things like that. And then we wanted to find the 10 most relevant grants that we could apply to and get funding for. So we kind of gave it that number so that it would be able to kind of provide us numbers of those grants. And then we also built a web scraper on our team to kind of scrape these websites and summarize relevant sections using Selenium. And so that was kind of like another huge part, was kind of being able to build that scraper so we were able to get information about the grants in the first place. And then how AI kind of like played a larger role is actually generating the grant itself, because as mentioned before, 40% of the time that's in these grant proposals is really dedicated to writing it, and having AI be able to kind of give us a lot of ideas or generate it for us would just take a lot of time off our hands. So we started off by generating step-by-step instructions tailored to each grant to complete the application. So we utilized AI in that, and our model kind of generated everything that we needed to do, or like a step-by-step process of everything we needed to include in the grant application. And then after that, those steps are kind of fed in again, and those steps were used to draft actual responses for each section of the proposal. But we recognize that, you know, AI isn't going to really provide a perfect response on the first or even second try, but something that we really wanted to do to make sure that the response was as refined as it could be was to kind of revise it, or like have it go through AI one more time for a final check, really with that compliance check aspect, which we said before takes like 15% of the time. So AI refines and enhances the responses to ensure the alignment with submission grant guidelines. So this is kind of how we incorporated technology overall, and utilized pre-trained models to kind of streamline the process. And then I'm kind of going to go ahead and show you some of our results early on, and what we were kind of getting. So this was one of the grants that we were given as a suggestion from our model of using. And so this was kind of like an artificial intelligence open topic grant. And so this is one of the ones that we were able to kind of utilize our model for in order to submit a grant. As you can see here, the objective was to provide potentially valuable small businesses innovation to the Army, and kind of expand the relevance to firms who don't really compete for these awards. So we were trying to see like, how could our work be like, how could we tailor our work to this grant? How could we, and things like that. So we were really able to utilize our model to help us with that, and kind of provide us ideas on how our work can support the Army specifically, and the objectives of this grant. So I know this is a little small, but I just wanted to like fit both of them in there. If you can see, a lot of this is really similar. This is the original one that the model like proposed, and then we ran it. Our model runs it through twice, so we actually get 2 versions: the original version and the revised. So there are some small differences in just like language, tone, words, usage. So on the first page, you'll see that one of the differences here is kind of just even in like the executive summary, right? Like, a pioneer in advanced natural language processing, machine learning, seeks funding. It's kind of just a chunky paragraph, but they really try to keep it sophisticated and make sure that everything kind of sounds like nice, especially because our model is like handling a large amount of information and might not be able to look at that. So there's a difference in tone and language here. Anote AI, a leader in advanced natural language processing and machine learning, is seeking funding to enhance its cutting-edge document analysis system. So just more concise, things like that. Later on, they also revise the content, so it's not just like they're revising the language and the tone, but more than that. So this is the second page. It's like they talk about RAG, they talk about a lot of the similar topics, but really just coming into making sure that the information that they're providing is really relevant to the grant and things like that. So those were kind of the ones we got. And then what we did was we used these original and revised versions here to kind of generate a technical volume. So we were really able to kind of compile everything into a technical volume, and we really saw that. So I had the opportunity to write a grant by hand at the beginning just to see how much time goes into it. And obviously it was a really time consuming process, but with this, I was just able to skim and be like, oh, I want this section, I want this section. And we were really able to generate a technical volume in minutes or hours rather than days, and be able to submit that really effectively. So it really did save a lot of time off our hands. And as for more of the technology that really goes behind it, again, for text generation, we relied on pre-trained AI models, and then we used RAG a lot, so retrieval augmented generation, and that came from TF, IDF, and cosine similarity. So term frequency, inverse document frequency is kind of this like method that's really used to, from a pile of documents or data that you have, really extract the most relevant words or whatever you're looking for. So in this context, we extracted the most relevant words from the grant descriptions and keywords to kind of source our grants and make sure that we were applying to relevant ones. And then cosine similarity compared grant descriptions with user input keywords to find the best matches. And on Anote's website, there's actually like a lot of like pages in the documentation if you wanted to read more on how the company itself uses cosine similarity, which I think is really cool, but that's also there. And then we also use web scraping to automate data extraction from grant websites. And then some challenges and considerations that we are looking in our model and kind of trying to solve going forward is like obviously the data privacy and security, but also making sure that these AI generated responses align with company voice and ethics, which isn't 100% guaranteed or ensured. Balancing AI automation with necessary human oversight. So even though we're having models and AI generate these grants, the issue is that we still need someone to look over it. We don't know how much time that will take. For us, it didn't take that long, but it really just depends grant by grant. And also potential biases in AI generated responses, which is kind of like an issue overall, and the need for continuous model improvements and deployment. So that's kind of what we're looking at going forward. And then, yeah, I guess like the key takeaways and future implications just come from like how AI has this potential to really revolutionize the RFP process by increasing efficiency and accuracy and really making sure that you're kind of sticking to the requirements of the grant, but also saving so much time off your hands. Startups and employees at startups have the opportunity to dedicate that time towards something else that might be more important. But also the customization efforts, automation, really just streamline proposal creation, and AI-powered solutions just really reduce the manual workload, really allowing teams to, again, put that time into something else. So I think that future implications across RFPs, past grant writing could be in negotiation tools and contracts, but we're yet to see where that is. I'm excited to explore that in the future, though. I know that our time is up, but I'm really happy to answer any questions through LinkedIn if you want to connect with me, or at Natan. I worked a lot with Natan on this, so he really guided me through this project along with the rest of my colleagues who are working on it. So he's obviously a great resource and tool, but I'm also happy to answer any questions through LinkedIn. But thank you so much.
Yeah, honestly, Sonia, you should be really proud of that project. I mean, coming in as like a freshman and coming out of Cornell, building a real world LLM Gen AI project to actually automate something that's very time consuming and tedious, that actually had like real business value and like helping us generate ideas for these proposals was like a huge add. And I'm really excited to see like how your career progresses in the next few years, and definitely reach out to Sonia on LinkedIn if you want to. So.
Thank you so much. Thank you, Natan.
Amazing. So that was an incredible talk by Sonia. Now I'd call her a great friend. Next up, we have Aisha. Hey, Aisha.
Hi, Natan.
So Aisha, and I met via the Breakthrough AI program, where our team Anote sponsored a few projects. One of them being this autonomous AI coding agent. And Aisha, did a fabulous job on this project. It was really her first kind of experience building multi-agent AI products, and I personally learned a lot from her, and I'm just really grateful for her, like kind of taking the time to speak today. A little bit about Aisha, she's currently a student at Hofstra, right?
Yeah.
And yeah, feel free to take it away.
Okay. Hi everyone, my name is Aisha. So thankfully I was introduced by Nitan, and I'm a junior at Hofstra doing my bachelor's in computer science and my master's in data science. I worked with Nitan on our autonomous AI coding agent, which I'm going to share my screen right now so we can start talking about that. Okay, do you see my screen? Okay. All right. So, as Nitan mentioned, I worked on this project under the advisement of Nitan. And yeah, I'm just super excited to share what an AI agent is and talk about my project. So, first we'd be thinking, well, what is an AI agent and what makes it different than a traditional large language model chatbot? And it's the fact that AI agents are autonomous and they can interact with their environment, collect data, and they use this data to perform self-determined tasks to meet their predetermined goals. These goals are set by humans, and the AI agent will independently choose the best actions to achieve these goals. And the key components that make up the AI structure is the architecture, which is the base that the agent will operate from, the agent function, which determines how data is going to be collected, and the agent program, which is how is the function implemented. The data collected by the AI agent is essentially translated into actions that support the agent's objective. Well, how does the AI agent work? Well, the AI agent will receive the specific instruction and goal from the user, and these goals are then broken down into smaller actionable tasks. And to act on these tasks, the AI agents will require information, and they will actually acquire this information themselves by extracting data, searching the internet, or even interacting with other agents. And to go on further, they will use this data once they deemed it's enough information. They use this data to methodically implement the tasks at hand. There are various different types of agents, such as simple reflex, learning agents, model-based, goal-based, and utility-based, and hierarchical agents. There's various benefits to implementing AI agents, such as improved productivity, because AI agents are autonomous intelligent systems that can perform tasks without human intervention. Reduced costs, because agents are able to reduce unnecessary costs from process inefficiencies, human errors, and manual processes. And AI agents are able to use machine learning and gather and process massive amounts of real-time data, which allows informed decision-making, and also improved customer experience. Because AI agents are autonomous, they're able to personalize product recommendations, provide prompt responses, and innovate to improve customer engagement, conversion, and loyalty. So for my project, I focused on using Crew AI, which is an open source framework that allows you to create a group of collaborative autonomous AI agents. Specifically, you can specify the goal, the backstory, and task per agent. And this is a tool that is meant for developers, but it follows an intuitive framework, which makes it very easy to use. So for an example, here's one of the agents that I had declared in my project, where you can see that you are defining the agent and the tasks that must be achieved. Tasks could be achieved by various agents, just in this example, that's not the case. And it will follow a sequential or hierarchical process if you declare a manager agent, which can delegate tasks to other agents. And one thing that's very cool about Crew AI is that you can use tools that they have provided, or you can define your own. So to focus now on my project specifically, I'm going to go into how does the actual project work. So for my project, the agents will first create a backup of your local code base. It will analyze your provided code base for potential new features, so for apps and things of that kind of nature. It will generate and implement this new feature, and then it will go further on to create a pull request in a user-provided repo for the new feature added, and then at the end, it will actually restore the backup that it created at the beginning of the process. And just for a better visualization of the workflow and how the agents are working, you can see here we start off with the user-given path to the code base, which goes into a feature generator agent, which is kind of like a product manager, who will generate a feature for a software engineer agent, which will actually take this feature and then start to try to implement this code to actually have the feature up and running. It's not fully integrated into the code base because it has to go through a code review, just like how it would in a typical software development environment. So the code reviewer agent will go through the code, make sure that the comments are enough and that there's descriptive variable names, and also try to make sure that the code will actually work. Then this will go to the section manager agent, which now will take this feature and try to integrate it to the main code base. After it's done integrating the feature, it will create a pull request for the changes and then will restore the original files. So for this project to work, the user has to supply a personal token for their GitHub account that has access to read and create pull requests in the GitHub repo. Also, the user must supply the path to their local code base. So for demonstration purposes, we have a ultimate tic-tac-toe game. And you can see here that the feature generator agent analyzes the code base to identify potential features or improvements. It includes missing functionalities, optimizing code, or enhancing performance. And it has a file reader tool, which allows it to actually read the file. And it sends its feedback to the coder agent. Then we have the software engineer agent, which takes the feature from the feature generator, writes the code needed to implement the feature, but it does not actually update the file yet because it has to go through code review. So now we can see here that it has the code review agent, which reviews the code from the coding agent, enhances the code for readability, maintainability, and performance, and then will send the code to a section manager for integration. You can see here, this is like a little bit of the changes that it can make, where it can improve board initialization, guard clause for player moves, and optimization for history update. Now we have our section manager agent, which will go through the code that's been given to them and try to implement this new feature into the existing code base. This is the agent that has the file writer tool that has the power to actually modify the files. This is the final output until it goes to the pull request. There's still, of course, new features that can be added to the app. And these were some of the new features that were suggested by my AI agent, which included timers, user profiles, an AI player, game analysis, and hints. And here's an example of what the pull request can look like. And here is a live demo. So I'll go and share my screen. Okay, to run all. And you can see here, first it's going to say that it's denied, then it's going to go and try to find a way to navigate this. And you can see here the software engineer agent is now going to implement this new feature. And now we have the software engineer section manager going to implement this code. You can see now we're doing the pull request. And now if we go back to the GitHub repo, we refresh, you can see the agent feature request is here. And you can see there's new files changed. We have a dashboard now that has login frequency and all these cool new features that the agent has come up with. And that's all. Thank you. If anyone has any questions, I'll be happy to answer.
Wow, Aisha. Every single time I see that demo of what we built, I'm like, wow, I can't believe we actually built that. You can imagine like in like the best case, like we actually got like the models and algorithms to work really well. You can imagine this agent that's autonomously pushing code. And then it's just kind of a question of like how well you can make it, how well you can evaluate these, how well you can improve these kind of coding agents. And you should be like really proud of this project. So
Thank you. Yeah, I love this project. It's super fun. Just hopefully we can create another tool that can actually run the code, and then from there, the AI agent can just fly off. And if it realizes the code isn't compiling, it can go in and try to figure out what the bug is. And I'm so excited for that.
yeah, me too. Well, anyways, thanks so much for your time and really appreciate you taking the time to.
Thank you.
Wow. Yeah. It's kind of crazy. We started that project in September. We got to like a POC in December, and Aisha was like one of the key contributors there. And, you know, I think it's a really exciting field, and I'm just really proud of like the work she did. Next up, we have Kia. Hey, Kia.
Hi, Nathan.
So Kia is calling in from Texas today. Also a Cornell grad alum. Yeah, and then he's building an amazing company, Eureka.
Yes, thank you, Nathan. We are New York based, but I'm traveling to Texas for a conference. Let's get started with the presentation today. Our mission at Eureka is to ensure that AI deployed in the real world is aligned with human values. And the topic of the talk today, which is contextual red teaming for vision model, plays a big role in how we approach this problem. AI and autonomous systems in general are already operating in the real world. We have seen AI agents making transactions on the web, all the way to the physical world, such as autonomous vehicles that are navigating the cities, there are autonomous taxis, and so on. The quality of the decisions that these autonomous systems make critically depends on the accuracy and quality of their perception systems. So in the case of the web agents, they should be able to sort of distinguish malicious and links that are fine to click on. And in the case of autonomous driving, the perception system needs to understand the contextual scene. They need to detect pedestrians, other vehicles, the traffic signs, buildings, and so on. But the real question is, how can we trust the perception systems of these autonomous vehicles and sort of AI agents? And also more specifically and precisely, how can we measure the robustness of visual AI systems? Before getting into sort of evaluation of robustness of AI systems, let's take a look at our own perception system. So look at the screen for a second. There's a gray bar in the center. Which side of this bar do you think is a darker shade of gray? I'll give you a second. If you're anything like me, the left side is obviously looks lighter than the right side of the bar. But if you look closely, the bar is actually the same shade of gray. So the context, which is in this case the background, matters in how we perceive different objects. And AI systems aren't any different, although the context of use and the way that they perceive context might be different, but context definitely matters in the way that they perceive the world. But are context in general considered in AI evaluation paradigms? Not necessarily. Like a standard way of evaluating these models is through some sort of a static testing. And we look at the average performance. If the average performance fulfills certain requirements, then we push the model to production. But context must be considered in evaluation. And I'm not saying that like context is never considered in evaluation, but the current approach is basically you decide on the relevant context, you go collect data, then annotate and process data, and then finally you go and test the model on that relevant context. In the case of autonomous vehicle, you can think of the weather conditions to be the context, the time of day, the terrain or the environment, like cities, urban environment to sort of rural environment and so on. And then the data is collected, annotated, and processed. But this entire sort of workflow is flawed in the sense that, first of all, you decide on the context before you annotate the data. Sometimes the context may change. Sometimes you may have forgotten to include the context that was really important for that task. The process of data collection is also inherently limited and biased because let's say that you want to collect data for autonomous vehicles, but you're located in like LA. How would you sort of collect data about like snowy weather? It doesn't snow in LA. So what's the approach? There's also counterfactual sort of scenarios that you want to evaluate the model on, or sort of really rare scenarios that are unethical to collect data from. For example, accident scenes. You don't necessarily want to cause an accident to be able to collect the data. That's unethical. And also, as sort of common in the ML community, 80% of sort of the model development pipeline is 80% of the time is spent on sort of annotating and processing the data. So that's a huge time-consuming, tedious process. What we do at Eureka is we eliminate all of these pain points. We provide a way for on-demand contextual red teaming of visual AI. So users can come in, describe their context in an interactive way. For example, in this case, they can say how well the model perform in mountainous terrains. And then the user agent interacts with the user and asks them more questions about like if they're interested in providing more context, like weather conditions, object of interest, time of day, and so on. And once the user is satisfied with the level of context they provided, the context agent takes that information into the platform, and after a few minutes, the user can explore sort of failure modes of the model in a contextual and an intuitive way. So in this case, the model is sensitive to different sort of lighting conditions, to different weather conditions, and then you as a user would know when and to what extent you can rely on this model. So there's a lot going on in the background that I haven't gone into the details of, but at a very high level, based on the context that the user provides, we take the platform takes that information. It's a multi-agent system. So based on that information, the platform generates synthetic data that is annotated already, so there's no need for human annotation, and then utilizes that sort of synthetic data and test the model on that data, and sort of extract the failure modes using vision language models at the end to inform the user on these type of failure modes. And our sort of services, these type of contextual red teaming is accessible to basically everyone, both developers and non-developers. We are providing API access to the contextual red teaming. And also, as I mentioned, you can directly sort of do the red teaming via the platform. You can just upload the model or provide it through sort of Hugging Face or wherever you want, and provide the context and just see the result without any need for sort of coding. But you may ask, like the red teaming is not necessarily the end. What happens after you find a vulnerability? Naturally, you would like to fix it. So we're not just stopping at automated red teaming, although it's the first step in the process of ensuring the robustness of the visual AI systems. But after the model is evaluated and these common failure modes are understood, what we call the data engine generates relevant data, diverse data for the common failure modes, and then the model is automatically fine-tuned on those relevant contexts that the user provided, and then those sort of vulnerabilities are addressed. So that's overall how we sort of close the loop for going from sort of bringing a model to testing it, to finding its vulnerabilities, and also addressing them. If you are interested in a sort of a more detailed demo, and also if you're a developer and you would like to access our API, please email us at admin@eureka.com. We're also growing our team. We are looking for both machine learning engineers and also software engineers to join our technical team. And you can scan the QR code that takes you to the application link, and you can sort of sign up from there. And we're looking forward to continued conversation. We're looking forward to democratizing the way that AI affects our lives. We want to have a say, and to some extent, we're empowering users to decide whether the AI that is affecting their life is aligned with their values and is robust. Thank you for your attention, and happy to take questions or take the questions offline.
Thanks so much, Kia, for the presentation. I think red teaming is obviously one of the most important things to ensure that generative AI models are safe and secure, especially when it comes to defense and security applications. Our team at Anote, we've worked with NIST ARIA on a few red teaming use cases, and I just have so much respect for what you've kind of built, especially in the domain of computer vision. It's such a challenging problem, and it's something that in the years to come will be mission critical.
Appreciate it, Nathan.
And thanks so much for taking the time to speak today, and hope to see you in New York soon. So.
Of course. See you soon.
What an incredible talk by Kia. Their team has done some really incredible research in the cutting edge fields of computer vision to help AI models be red teamed in a way that's safe and secure, which has huge implications for defense and security. So thanks so much, Kia. Next up, we have a really special speaker, PJ.
Hi, Nathan. Hi, everyone.
So PJ and I, we met when I was actually in Washington, D.C. at the AI Expo from the Special Competitive Studies Project. That was kind of like my first real exposure to this kind of incredible world of leveraging AI for USA national interests in the security era. And PJ has kind of done a lot of work on the strategy there of how to build the best AI and AGI roadmap. We're really excited to kind of hear his talk today. And without further ado, I'll let PJ take it away.
Nathan, thank you so much. And good day to everybody. It's my pleasure to be with you. I've had an opportunity to study AI. I for the last 10 years in different capacities, I kind of look at AI as any expertise. There's those who have done it their whole life. There's those who pivot to it from other expertise, and there's those who study it. I'm in this group. I've studied it in 2 years in something in the Pentagon called the Third Offset. It was a classified strategy to try to prepare for the modern era of military conflict. I used it in operational warfare for an unfortunate war that I think was necessary, called the ISIS war. This is the group that was sort of taking over northern Syria and northern Iraq and cutting people's heads off and stuff. And then came back and was responsible for the classified annex for the National Security Commission on Artificial Intelligence. So got to do some more thinking about moonshots in AI for the nation and how does national power accrue in AI. Went to the National Security Council to set up a technology competition portfolio there in the China shop, and then I've been working at SESP. First, you should all know that there's an awesome opportunity that's free to the general public and very substantially reduced to do an AI Expo in DC, where I met Nathan. We're doing it again this year. We expect about 20,000 people. Think of it as a mini CES, but in front of a big government crowd with a lot of venture walking around too. So that happens June 2 through 4 of 2025. With the rest of the time, Nathan, based on your cue, I want to lay out 7 general propositions for where I think AI is now and how it's intersecting with like the international competition. So I think for this crowd, most of this will probably seem self-evident, but I want to offer some basic derivatives of this. First of all, I still find it interesting when we brief people in Congress or elsewhere that there's still not an understanding that AI is a general purpose technology. And so when you think of general purpose technologies like the beginning of the machine age, 1780, and the steam engine, and machines are still with us today, and then electrification and electricity and machines like created the Industrial Revolution, then you have the third, automation, then you have digitization and the whole enabling of a domain that we're communicating on right now that was only technologically accessible. It was not accessible to humans until it became technologically accessible. I marked it with the first website in 1991. Those 4 general purpose technologies will never leave the earth. That's the nature of it. A general purpose technology subtends most functions of society, and then it sticks, it remains, it stacks, which means it combines with the other ones. So the 5th we really regard as AI, and the 6th we really regard as biotech. Those general purpose technologies are sticking and stacking. The other thing that's unique about general purpose technologies, they almost always come with alignment fears. And so the one that I'm most vexed with is electricity. When electrification created, when Nikola Tesla created an alternating current in 1890, when he was looking down on his lab bench just trying to get an AC current to store in a battery, it was very difficult probably for him to imagine the entire electrified Earth from space. Now you see like grids all over the world lit up. And that's the nature of a general purpose technology. You see it like small, and then 100 years from now, you can't even imagine it. But there were fears that when grids went, what were most of the homes made of in the West? They were made of wood. And so people were very afraid of the alignment issue of their homes burning down. And it in fact led to a professionalization of the entire discipline of firefighting just to make sure there was alignment with that general purpose technology. All of them have these episodes. AI is no different. So number one, AI is a general purpose technology. As a result, it will never leave the earth because it's general purpose technology. It's so useful. 2, it combines with the other ones, and that's where convergence really comes into play. I think it's a very important concept. And then 3, there's always alignment concerns. Usually humans get control of it and then use it for good over bad. And that's usually like the general trend that I see. Number 2, we think AGI is going to come in this presidency. So we use the DeepMind definition that has 10 levels of AI progression. If you haven't seen those, I should do it this way for you guys. 10 levels, 5 levels of narrow AI, 5 levels of general AI. And general just simply meaning it can do more than one task instead of just destroy a human at the game of Go. So it's generally useful, like Open AI's O1 when it dropped, it was crushing humans about 9 to 10% above benchmarks in most of the sciences. It wasn't just good at chemistry; it could do things in physics. And I watched it do things in physics that just rocked my world. One of the coolest things I've ever seen in AI. Seen it applied to very complex physics modeling problems at Lawrence Livermore. Just blew everybody's mind. So it's like more general, right? And so we think like the next level of general AI will come in this presidency. I do believe what a lot of the labs are saying is that will come this year. So number 1, it's a general purpose technology. Number 2, general AI is kind of here at level 1, level 2. The next levels will come. So when someone says AGI will arrive, I really mean the next levels will arrive. We can talk about what is super intelligence look like. I think there's a simple path to that too. Number 3, we think there's 3 ways that AGI will arrive. We basically try to explain to people who are not doing AI, like most of you, that there's 3 trends to watch. And there's the trend of the generative AI models themselves and scaling laws and upsetting of scaling laws like DeepSeek R1. We all expected that to happen. Number 2 are the novel paradigms like Nathan works on, right? Like I've looked at some of the different forms of AI that Nathan creates, and I've been mesmerized with few-shot learning for years. I think it's amazing. I think there's a whole run on few-shot learning that hasn't even happened yet. Few-shot learning with agents, few-shot learning with agents and a bit of memory. I mean, some of that stuff will just tool call to LLMs like you Google stuff, right? And they're just going to be amazing. So we call that the novel paradigm trajectory. And then the third is just the infrastructure itself. It's well over 100 billion. We think it's a global $1 trillion game of just building AI infrastructure, even though there's offsets to things like big data. So the models themselves, novel paradigms that are combining with them and with each other, that are LLM independent or interconnected, and then to the whole infrastructure game. And we're not even talking about the arrival of quantum. If there's any questions about that, I do think we'll see like million qubit fault tolerant computers by like 27, 28, and then it becomes commercially available in the 2030s. So number 2 is like number 3. I'm sorry. That's the 3 ways we think like AGI arrives. Number 4 is we think there will be offsets in here. We think that it's so useful that people will make it better, faster, cheaper, smaller. Like DeepSeek's just like a little reminder of that, right? And so we're not surprised by that. We expected that. And the only game there is how much of it is publicly adopted by governments and how much of it is driven by private sector. That's its own story. Number 5, I think these offsets mean opportunities for everybody. So for those who are working on AI, like the brief I just watched before mine on red teaming, offsets to me means there's unlimited opportunity to make those offsets, to be the company that has a niche in those offsets, to even take something that's already an existing paradigm and apply it in new ways, to new fields, to new businesses, to new verticals. So I think that offsets mean that this is just going to be, AI is going to be completely offsetty in a way that other general purpose technologies were not, like fission energy and stuff. There's only a few people that can play in that game. This game can be played in by anybody that has competence and will. And it's even being played in by significant actors. Some of the hyperscaler labs were created by people who pivoted to it themselves, were like journalists. So it's an incredible, offsets mean there's opportunity. That opportunity to me feels largely unlimited. I think it will have a run that will go, literally could go 100 years more. So hope that's encouraging. Number 6, this whole competition is being fueled by the 2 largest economies in the world. So that's another thing that's really distinct. The machine age, electrification, automation, digitization. You can't honestly say they were fueled by the 2 largest economies in the world that operate to the tune of like 30 trillion, 26 trillion. And both of them are all in on like driving this technology to fundamentally good purposes, right? So that's unique. You're living in an era where the 2 largest economies are like hyper focused now on this tech. And then, finally, if you asked me what's the most important thing the nation should do, is that we should envision the most productive and audaciously good positions in AI to occupy that are not here yet and go create them. That's the definition of a moonshot to me, right? Is that what people think is possible, what's actually possible are never the same. You need some sort of stretch goal to actually achieve what can be achieved without going to crazy town. And that to me is like what Manhattan was like. That's what Apollo was like. That's what Human Genome Project was like. If you want to look at something recently, I think Warp Speed was like this. mRNA is sitting around. It's like DARPA funded. It's sitting around two big pharmas. And then all of a sudden, you have like people dying, and then you see mRNA ramped up. And now it has amazing potential to be used for other things. And people are even now exploring cancer vaccines. So my point is, the first thing you would do, if what I've said is true, it's a general purpose technology, it will stick and stack, it will remain forever, and there's always these alignment things that tend to work out. Number 2, it's like the general form of it is even going to be more useful, and it's coming, and that there's these mega trends that are hundreds of billions, trillions of dollars driving its achievement. There will be offsets. Those offsets create opportunities. That's where everybody enters in that's creating this. It's fueled by the 2 largest economies. What would you do? In my view, if you're what would you do if that's even half true? I think a wise nation would think about these really audacious goals and then set them and then draw in talent like everyone who's on this meeting right now to go take it down. So that's my simple presentation. These are 7 propositions I think that are fundamentally driving the era we're all living in together, and I'd be happy to take any questions. Till the next one.
Wow, that was very insightful. Thanks so much for just like taking the time to like speak with our audience today.
Yeah, thank you, Nathan.
I personally do have a question, right? So a lot of people, at least
Yeah.
within our AI community, are always like looking out for like these audacious, really ambitious AI projects that can bring people together.
Yeah.
I guess I kind of agree with your perspective that kind of aiming high is always better than like aiming for like low, because the worst case, if like you shoot high and you miss, at least you're at the stars, right? So I
Exactly.
guess, do you have any ideas on like what that type of like ambitious AI project could kind of like look like that maybe
Yeah.
is something that would unite the nation over the next few years?
Yeah, it's a great question, Nathan. I would offer a few. First of all, I'll say there's one really, really cool classified one that moved out of the AI Commission that I think could fundamentally make the world so transparent it'll change like deterrence theory between rival nations. And so you might imagine something like the ultimate intelligence fusion engine, right? And as easy as that sounds, doing it in the real world, instrumentalized real world data that spans various classification levels is actually not that easy. But if you could create it, that would be cool, right? The second one that's easier to talk about, that's actually a bill now, is called MedShield. MedShield it basically says this: whether COVID was an accident, zoological, uh, you know, or a weapon that was, got loose, whatever you believe where it came from. The fact is, it's just the beginning of forever with biotech. Now that biotech is a no general purpose technology on the earth, we think accidents or man-made things will happen quite a bit. I actually think states who have nuclear asymmetries will look to bioweapons in time of war to match nuclear parity. It's a concept called stability and stability paradox. So, what would you do? I think I would create an AI-enabled kill chain against pathogens to like defend us and the free world against such things. So we've conceived of something like that called MedShield. It would cost like one B-2 bomber. It's like $2 billion to build. And so that's a bill now. It's not appropriated, but like that's another one. Going beyond that, we've imagined something and written about something called alpha strategy. So if you read a book called Competing in the Age of AI, it's probably what's true of companies is probably true of governments too. So that's a proposition that's worthy of interrogation. But the basic argument is the core of the modern firm will be an AI-enabled decision-making factory. The company with the best firm will kill the other firms. So what if that's true of government? What if you had like an alpha war, alpha econ, alpha intel, alpha diplomacy, all instrumentalized into an alpha strategy to be like not ever do decision making, but to be the superior recommender agent with you. And like if you knew like Russia was building that, would you just say like I'm good with facing that and we shouldn't build that, or would you say it's better to be Lee Sedol and AlphaGo playing you at Go? So that's 3. We've written about that. That one's really rough. I've argued it across government. The reason it's so rough is it's really not clear who would own that. DARPA has done work in this space, but could they own and operate such a platform? Like, so let's say for the National Security Council, not clear. Very, very. There is a conference coming up in March called DECIDE. It's an acronym where a lot of the national labs are getting together to work on this because they're not sure who the owner is. Those are 3, right? So, imagine like amazing fused intel changing transparency so you could pre-bunk like assertive bad things before they ever happen, and that kind of accountability could change the game in some ways. It would never stop evil, but it could really curtail it. And then 2, like what does it mean to just use AI to defend ourselves biologically in the biotech era, because mistakes are going to happen. And 3, what does an alpha strategy agent look like? Those are 3. I think there's more. We had 7 in the annex, but that's just to give like a sense of like, to me those are doable, right? We've even suggested there should be an AGI system in DC that the government can kind of call its own for 3 big reasons. Happy to talk about, but we think there should be a platform that's made for national security so that government officials could pet it and call it their own.
Wow, that's really, really interesting. Yeah, I've always felt like when it comes to like AI for national security, it's kind of like if we aren't able to win as like a country, that battle like will be in a really bad spot. And
Yeah.
it's like there's all these kind of really incredible advancements both in the models with agents, with on the data side as well. And it's really incredible that what your team at the SCSP is kind of doing. And we'll definitely, be at the AI Expo, and we kind of encourage everyone from our community to kind of attend and support and serve where they can.
Yeah, thank you so much. Like we're a 501(c)(3), so you might think of us as like a tech charity funded exclusively by Eric Schmidt. So we're not for profit, and we don't even charge attendance at the expo. It's free. Um, and it's substantially discounted for startups. And we do have 16 spots left on Startup Square. So feel free to throw out my email, and be happy to link you up to the team that could get you into the expo. It's going to be cool this year. There's already a lot of people, like big names, that are coming to speak, and companies that are going to reveal some cool stuff, like a mini CES, but more for like national purpose and mission. Thank you so much, Nathan. Great to see everybody virtually.
Amazing. Honestly, like what PJ and the team at Special Competitive Studies Project are doing is remarkable work, and is probably some of the most important work going on in the AI field today. We should all just be very thankful for their team. As you mentioned, a nonprofit dedicated to helping AI stay ahead in the national security, USA stay ahead in the AI and for national security space, and obviously a lot of good ideas too. Next up, we have Arjun and Bhavani. So Arjun, I'm gonna admit you. Essentially, PJ also kind of shared a link to the Expo SCSP. I'm gonna put that in our Slack channel for everyone who wants to join. Let me, while we're waiting, I'm gonna essentially put a link to our QR codes. Let's see if this works. Join our Slack channel. Yeah. Do you see this?
Yeah.
Yeah. Join our Slack channel. We'll share the link to the AI Expo conference, and yeah, thanks for scanning. Let's get it in. Like I'll hide it in 5 seconds, and then we'll kind of get this started. Yeah. Great. Hey, Bhavani, how are you doing?
Yeah, hi Nathan, doing good. Yeah. Hi
Awesome.
everyone, listening to it.
Well, I'll kind of give you guys a quick intro and let you take it from there. So Arjun and Bhavani have been building a company called RTRVR.ai.
Yeah, retriever. Yeah.
Yeah, it's a really like incredible product. It does a lot of really incredible AI agent workflows for computer use and web browsing, right? And we'll let you guys kind of take it away.
Okay. Yeah, so I guess I'll share the screen. Okay. Hopefully you can see it. Yeah. So thanks for everyone for taking a quick look. So we're here to demo and talk about the AI browser agent space generally. And our startup is retriever.ai, retriever, no vowels. It's tricky we're getting some tricky feedback, but yeah, so our whole goal is it's a Chrome extension that can do tasks autonomously on the web, retrieve structured data, and do like call third-party tools or APIs, all with natural language. So yeah, we could quickly go through a little bit of our side. So I'm Arjun. I used to work at Google Ads doing vertical federated learning. So setting up models, training architecture in such a way that you could train models in silos. So like the features and labels could be in silos, and the raw data would never leave those silos as you train the model. And as soon as ChatGPT came out, I was hyped about its applications to how it could like help people. And I can let Bhavani talk about her background.
Yeah, as you know, both worked in the Google ads, especially dealing with billions of users' data or like processing them securely. Um, that's when we realized that there is much more need for such a high level processing of transparent data exchange in the rest of the worldly applications too. That's when we started brainstorming about Retriever to build a transparent, highly scalable data exchange and provide the agentic tools for all the providers as well as data buyers to be able to generate data at scale. So yeah, we can get started with our agent.
Yeah, so it's same as the website. So like a little background is like for a lot of people, the browser is the bottleneck. Me personally, I have thousands of tabs open and I'm constantly context switching. And you're kind of just copying data from one tab to the other. And this manual data entry kind of kills productivities for for different kinds of jobs or like sales jobs or other jobs where it's like you have to just click through and manually copy paste, and which are things that AI could help us automate, right? And a lot of companies actually hire scraping services offshore that to get, like just manually extract data from these websites, and they're okay paying X amount of money. And another way people are getting around it is like RPA bots, right? You set up automations, but these automations can break. They're like the website updates and like it's like all gone. And but like AI agents kind of solve this because they're generalizable. They can, if the website changes, they can it's not a problem for them. They'll still can figure out what to do. And yeah, like if you are thinking of the other side of agents, that way people are structuring it right now, it's like I have this agent, it has access to 10 docs, and I'm going to constantly update the permissions from the underlying doc to the agent's permissions. And it's like you're kind of duplicating these like permissions, and you're siloing the data that is not available to your everyday user. So our take on this is having a Chrome extension that can do actions on the current tab, as well as all the tabs you have in the background as well. Or you can give us a Google Sheet of a column of URLs to interact with, and we'll open them and interact with them. And as I mentioned earlier, we also have like function calling that allows you to just with natural language call the APIs you need as well. So it's like combining the web and API layer into one single interface with just natural language you can do actions on. So for example, if I just give this command of like find Retriever's LinkedIn page and follow, our agent goes through our agent goes through and searches for Retriever and I'll give it one more shot. Clearly it's having issues with the name as well, but so you can see it search for Retriever in the search bar, and it will click through, like, so it can take actions on the page such as typing, clicking, selecting drop downs, and do the goal that you wanted to. And it can do this as part of a data extraction tool as well. So you could say, yeah, so we're already following, so it doesn't matter. And so you could say like do X task and then extract this data to Google Sheets. So like one common case could be like, hey, I'm on Hacker News. For every article on this page, like extract all of this data to Google, like using our like export feature, which natively has integration with Google Sheets. So it will construct like a JSON basically for all of these like elements on the page and write to Google Sheets. So it's like a way to scrape data without like you getting technical at all. You honestly, you could have just pressed a button and it would have figured out as well like what you probably wanted. And so it's like zero effort almost. And this could be useful for some of this other feature could be useful for some of the more technical people that have like hundreds of research papers to read through, maybe with all the latest AI breakthroughs. So if you're like on archive and you are just saying for the first 5 papers, open the PDFs and extract this like information, um, our AI agent will like be able to like using this explore feature to go through the pages as well as like explore the links as new tabs with sub tabs that
So essentially like a deep crawling of
yeah.
the second level of crawling too.
it didn't work, but maybe it will work again. So it's still a little finicky on the latest with the latest Gemini models. We recently upgraded to 2, so we have to rework everything, as someone who's working more downstream has to figure out. So as you can see, it opened these PDFs that are nested, and it can extract the information from these PDFs of like the data we wanted, of like the title, top author, and like a summary. So, but you could have it like even more nested. Like you could ask for tables in this PDF as well. So it has written most of them. It has written all of them here, and yeah, I think the other actions you can do is like do actions across tabs. So say like we have our own take on deep research, where if you have a bunch of companies and you already have them as open tabs, you can select them and give like a research query, like analyze these companies by strategy, features, pricing. And we're kind of using like your own sites that to do research on. So we will take action on these sites and like go to the pricing page to figure out, like, to answer this research query. And this is like a novel concept because like OpenAI's deep research as well as Google's deep research, they only have access to the public web. So maybe you have local files, like a local directory, or you might have like paywalled sites that only like customers will have access to. Um, or like login walled, paywall sites. None of these are available to these to Google or OpenAI, and we can take actions on them since it's just you. It's as if you're browsing on your local. It is you browsing on your local web. So yeah, it allows like a whole new it allows a whole new set of sources as well, and you're more in control of the sources. So what we found with our experience with Gemini's deep research is that it's like the quality of the sources matters more than the like underlying model. So like, why is Gemini deep research so good? It's just like Google searching your topics, figuring out what to Google search, and taking the top X results from that. But we think you are much better efficient, more you are much better arbiter of quality. And you can, if you have your own sources that you would like instead of like random Reddit pages, then the quality of the research output should also be better. And instead of like long reports that, you know, we have some doubts on if people actually read those reports like end to end. Our take on this is like, hey, you have X dimensions and you have Y topics. Like a condensed matrix to represent this information is more useful to the end user. If I want to compare the strategies of Retriever and like Axiom AI, this is much more useful to me than like reading through a very long report of like to get the same information, like looking at section A and then section B. So yeah, if the best use case of AI so far is like summarize, then like writing a long report doesn't seem like the best product market fit for these kind of AI deep research tools. And yeah, I think that's mostly it. I can show a quick demo of like our feature to extract data. Like if you just have these kind of if you have like X Amazon tabs and you just want to like extract them, like you can just click one button and we'll automatically define the schema and be able to extract the data automatically, and you can use it for like reference later on, like if you're comparison shopping or yeah. You could yeah, also like close the PDF type. But like if you had like PDFs, you could select all of these bunch of PDFs or Google Docs and ask to like get you can ask to summarize across tabs or like ask for comparisons. And
Yeah.
yeah, let Bhavani take over. I don't know.
Yeah.
Go for it.
Yeah, let's look at some more cool use case. I know, like you've like looked at bunch of features of Retriever. That shows our passion for like building this project for sure. um, the one of the best features of retriever is like function calling. We do not have any tight integration with one or two providers, but a dynamic integration with any tool that exists out in the world. All you have to do is generate the integration using LLM. Say, for example, I have test integrations with Slack. We have integrations with creating data analysis graphs. Literally, you can do like a WhatsApp integration or anything. Say, for example, I have like a Slack integration where I can invoke this Slack integration to send messages to channel or replies to people as such. We all have been subscribed to so many newsletters. It's hard to read these days, right? So I'll ask it to generate a quick summary of the newsletter here and send me a Slack message.
You're not sharing the screen?
I am now.
Okay, now I can see. Sorry.
Yeah, maybe it wasn't
Oh.
focused earlier. Yeah. So yeah, as you can see with the extension, as I mentioned, we have like a Slack message function here, right here. And then I'm asking our agent to like send me a Slack message with a quick summary of the newsletter here. So what it does is like it works seamlessly on your email, on your web, or like any web application out there. So it tries to generate a summary and like creates like a function, invokes the Slack messaging function and tries to like send the message to you. So as you can see, like yeah, I'm in India right now. So it successfully sent the message. Like the newsletter talks about the Sam Altman's comments on Elon's bets and so on. So yeah, get away with reading like tons of newsletters when you can get the key points right in your inbox for you. And let us do like a couple more things. We all deal with so many design docs, so many internal PDFs that are not even web, but are inside your corporate internet or like corp internet. The best part of Retriever being an extension on your own browser is you can access those internal docs as well. Say I have these design docs on AI Web Agent as well as design doc on like thinking LLM models, which is the rage right now. Now I want to like extract some data out of it, right? So like give me top points and summary. And all I have to do is like ask across these tabs if you want it in a text format or if you want to extract it in like a Google Sheet format, in a structured data format, you can go for extract. So it processes the docs, extracts the relevant data that you want, and like yeah, opens up a sheet and gives it to you. So as you can see, it's like blazing fast stuff like, yeah, what are the docs and what are the top key points on these and like summary as well. So imagine you're like dealing with thousands of internal docs, thousands of external websites. Everything is seamlessly possible with Retriever. And one more thing I want to show is like our cool data analysis feature, which is our like graph bot feature. Say the same stuff. You're dealing with a lot of like market research data or so, and you want to like generate like a data analysis report on top of the data. Here we have US state with the population estimates on a website. So by invoking the graph bot, it automatically generates the graphs on any form of structured data that's been provided to the retriever. So as you can see, the number of functionalities and features are like infinite with retriever, and that takes us to like how we are different compared to like many other AI agents out there in the market, right? So one of our key technological differences, we are a text-based agent compared to like a vision-based approach or vision-based agentic approach by Claude or your OpenAI operator. And how is it better? So one, text-based. The way we approach text-based is we represent these web pages in an exhaustive and comprehensive way so that it's like zero hallucination or like bare minimum hallucination from the LLMs. Compared to vision-based approach, there is a very pretty high chance of hallucinations, which you might have seen in Claude clicking the Yellowstone article or even operator go taking so much long to even get a task done. And also you might have heard of browser base or other browsers that exist on the cloud, that are really extremely costly because they have to pay for the proxies, and the browsers are running up in the cloud. So you do not have like a control as you have control on your own browser. So also, because it's running on like a generic browser on the cloud, the results that you see are not personalized. By having an extension such as Retriever right in your browser, you can see the personalized results and you can process the data on top of it. The best part, you can get access to all the paywalled content and even your internal corporate websites. And because we are leveraging a text-based model, as Arjun mentioned, we get to process the tabs in the background and multiple tabs at once. So you can do your work and let Retriever do work in the background. So yeah, that's like the true productivity unlocked right there. And
I could just add on a little bit, maybe. Yeah, so I think what if you can go back to the previous slide, I think some things to add on is like what in our discussions with other players in the space, it actually turns out that hosting like a cloud browser and setting up proxies dominates the LLM cost. And similarly, there's like a reason why you don't stream a browser to your like to do your daily browsing. They're actually pretty resource intensive, and it's kind of like one of the most resource intensive things that the average person uses. So we don't think it's not scale. We don't think it's scalable approach to do like operator for everybody. Like you definitely need it needs to be some local resources. And the reason why the vision-based approach needs to can only be done on the active tab is that the browser itself doesn't render background tabs. So it physically cannot, like, otherwise it's like going to consume a lot of resources to render all of your 1,000 open tabs. So that kind of like they're using the vision approach as like a short gap, which turns into like shooting yourself in the foot long term in terms of what you can do with this kind of technology. And yep, I think that's mostly it.
yeah,
Yeah.
do check out our extension, to give it a try. We're really open for feedback, and lots of exciting features up in the pipeline. Yeah, and please reach out to us at support at Retriever or founders at Retriever. Thank you so much.
Thank you so much.
Thank you guys so much. And maybe put that QR code up there one more time. I think everyone should go and check that out, right? This is a very, really incredible technology. So, you know, I'm personally going to go check it out after this. So, yeah. Well, anyways, yeah, QR code. Great. So thank you, Bhavani. Thank you, Arjun. Thank you guys once again. And yeah, it's great meeting you guys. I can't believe this is like the first time we met, but hopefully we'll kind of, for years to come soon, friends. So anyways, we're gonna take like a 2-minute break in the stream. Sorry guys, but we need to make sure that we can effectively record all the talks. So I'm gonna essentially end this stream and then start a new one. And then next up, we're gonna have Sam from RoboApply in 2 minutes.